Hello and welcome to the Saturday section of the AEC Hackathon. We are starting out with Molio plus Covi for this cool program. Aside of Molio and Covi, we also have a mentor session by PropTech. We do have RB Software, short breaks, Henning Larsen with their tech talk. And we will continue with Dalux, ARA 3D, and a podcast by Zero. All summing up to become the Saturday in our program, continuing tomorrow with breakfast, lunch, presentations, feedback, and the winners of the hackathon announced. So without further ado, Michael Ambjørn from PropTech, welcome.
Thank you, Eske. All right, welcome to the Saturday at Blocks Hub. We've got a strong audience here, both online and around the world, and of course in the room where we have hackers basically working away at some of the urgent challenges of today throughout the building and basically culminating all tomorrow. But for now, we've got an expert panel, a very strong panel actually, with us here to talk about net zero. We're going to be talking about corporate startup collaborations. We're going to talk about new solutions. We're going to be talking about the practical challenges. I've also put these questions out on the LinkedIns. If you're familiar with that, you can, if you look me up, you'll find it there, and you can add extra questions, also resources that we should take account of, and so on. But first and foremost, it gives me great pleasure to introduce the panel. First of all, old friend of the house, and also basically co-conspirator on this panel, along with Niels from Covi. We've got Ole Berard from Contact Lab, which is part of Molio. Ole will be shortly giving a brief presentation to lead in. Please give Ole a warm welcome. And up next, we have Tia from Into Labs, actually also based out of these buildings. And you'll also be sharing a very brief presentation. We have Niels from Covi, and again, a brief presentation. And then the odd one out, which is Tyler, who stepped in last minute to basically help out as Simai from Compass VC was going to be here until she wasn't, and so you are basically the backup, which also means that you won't have to do a 3-minute presentation up front. So exactly, sweet offer there. We put all the people up here, we more or less in that sequence. The chap there, that's definitely Michael Ambjørn, in case there are any complaints, just to be clear. Great. We'll get started with the presentations with a little bit of help from our hardworking technician. We're going to hand over to Ole first, and I don't know whether you to Niels first, and if you want to basically come and take your spot here, definitely. And then take it away.
Thanks a lot. And
I think you need to use the one that's on the table, maybe.
There we go. So that's me. My name is Niels, and I come from a company called Covi. We are an engineering and architecture company working in Scandinavia, UK, US, and every year we run a startup program that I just want to inspire you with, and that's also why we are here today, because what is really important for Covi is that we are a very big company, we're 8,000 people, and we are fast but also slow-moving boat sometimes. Decisions take time because you need to implement it with a much more people than in a startup. So in order to get the best of both worlds, we run this co-creator program every year, where we basically invite in a range of startups. And the idea is, let's start with the feedback. So why are we doing it? Well, what we've seen, we've done it for 5 years now. We see that we get a lot of agility and innovation into a very short period of time. We run a 12-week sprint with these startups. And you can just feel the energy because people get committed. They need to solve a business case challenge within 12 weeks. That definitely does something both to the startup, because they're motivated to get engaged with a large corporation, but also for a company called like Covi, because we're eager to understand what is the latest trends, what's going on out in the world. We get a super high satisfaction from these events, both from the startups, but also from our employees. They are really happy to get inspired with something. If you sit down in your projects every day, it's nice to sometimes get up and look around at what's going on in the world. So we get a huge satisfaction from that. And then we always try to involve customers in the journey, and that's a super good discussion. Instead of just talking to the on the specific project with the customer, we get an opportunity to talk to the customer on their long-term strategy. What is it that they actually need to solve, and how can we solve that in a better way together with startups? So that's basically the idea. Here you just have an idea. It's actually a pretty long step. We start started in November this year to talk to the market in our organization. What is it that we see our customers need? Where are they challenged? Formulated some challenges, went out, screened the startup industry. Where could somebody help us? And then we selected them now. Ento is one of the ones that we are now going to work with for the 12-year sprint. And in June, we're going to stand on stage together with Ento and present how do we see a potential business case where Covey and Ento, for example, could do something together. So really exciting about that. So that's where we are working with startups, and I'm really looking forward to talk about what the potential is then in that.
Thank you so much. All right, and then up next we have Tia. Come on up.
On, which
Yes, you do.
is helpful. Hello, everybody. Nice to see you. Let's see if I can get this to work. Yeah. Hello. So my name is Tia, and I am Ento's data integration lead, which means that I have the pleasure of hunting down energy data in our 11 countries on a daily basis. This is electricity, water, gas, district heating data. And then I onboard the data on our platform, run our AI analysis, and hand it over to our data science team to have them verify the potentials. And we do this so that we can help our customers, which are large building owners, energy optimize, save energy, CO2, and money, which is a lot of fun. And I suppose that's also why you're here today. I think that you know about this, right? That sadly, about 10 to 30% of energy consumption in buildings are wasted. And there is no need for this. And I hope that smart people like this, in a hackathon like this, can work together to solve this issue. Because to a large extent, we actually already have a lot of the data and the solutions to do this better and to minimize energy waste. And that's one of the reasons why we do what we do at Ento, because we really want to unlock the value of this fantastic utility and building data for our fastest, most cost-effective and secure green transition. So it doesn't have to be hard, actually, to do this. We work the best that we can to actually make it as easy to get started quickly and also to work very sustainably. Because we prefer to use existing infrastructure and data to then get started quickly and run our fully automated AI analysis. Just recently, we have worked with some large language models to actually look at the time series that we analyze with our AI and then come up with what is the most likely fix to this issue. Should you fix your radiator? Is there something with your ventilation that's running off hours? What is it most likely that can be fixed so that the building managers can actually go out and fix the issues quite quickly? And then we also help them to automatically document their savings and their verifications. As you probably know, there are increasing demands to how we should live up to certain standards on a national and an EU level, etc., in regards to sustainability. And the data is really helping us a lot in this, and we have a lot of good solutions as well. So just a brief note about what is Ento. These numbers are actually from December, so pardon me for not having updated them. We're growing quite quickly, so I've been focusing on doing work instead of updating slides. But we have more than 125,000 meters across 11 countries and more than 30,000 buildings that we're analyzing on a daily basis, which means that we are tracking more than 4,000 gigawatt hours of consumption on a yearly basis. And we're helping our customers to implement more than 2,000 projects as of December. And we have helped them to save more than 13,000 tons of CO2 equivalents on a yearly basis, which is quite a lot. And this is, as we talked about earlier, that's an average saving of 5 to 20% per customer. This is a slide of some of our customers. So the 5 to 20% is actually quite a lot. when you think about that, our smallest customer owns properties worth more than 1 billion kroner. Yeah. So I look forward to the discussions today.
I love the one saying London Borough and then Aalborg Kommune.
Good. And that's a great point as well, because I love that it's going to be very interactive today. So please come with your questions, because I'm really here so we can work on using this even more. Thank you.
Fantastic. Thank you. Please give Thea a warm hand there. And then last but not least, we have Ole.
Yes, thank you. What's it called? As Michael said, I'm from Contact Lab from Molio. I brought some recent results from our survey, from our maturity survey today. I did not translate all slides because it was released on Wednesday, I believe. So I tried to translate the main points in these slides. So one of the good news is that 3 out of 4 Danish companies have a sustainability strategy, a strategy for decarbonization by now, and has been increasing a little bit over the years. But there's still a lot of challenges when working with sustainability, and one of the major challenges is to find the data, to find the time to make all the reporting, all the ESG and CSRD and the LCA ST calculations and all these nice acronyms. It takes a lot of time from people, and it takes a lot of data, which is hard to collect. I found this post here from Lisa, which I think is actually very good because it's very true. It's most environmental data is unstructured. It's difficult to collect. It's difficult to organize. It's difficult to report on. But that's actually what AI is good at. So the point is, there's hope. There's a potential to use a lot more technology in order to fix this and to save time and to make better data. So even though, not only data is a challenge, also technology is a challenge. There's hope to innovate, and actually the industry also realizes that. They also believe that the digital tools, so the knowledge that it can help is there now. It needs to go to action. Just wanted to show this because I think it's cool, and the most important part of our survey is to see how stuff develops. Actually, AI, what's it called, quadrupled last year from 5 to 21%, and now it doubled again. So it grows very, not surprisingly, very fast. I think also what's it called, project platforms like RIBs and Dialogues over there, they also also growing, which also does something about the data. What's it called? The data availability. So all in all, there's plenty of reason to innovate, and there's actually a good foundation to innovate some more. And I think that's the words for you to start the debate.
Right. Please give a warm thank you to Ole. Off to the races. We're basically going to start off with Tyler. You don't get any slides, but would you just briefly say a little bit more about basically the work that you've done between corporates and startups and basically some of the topics here?
Yeah, okay. So I'm Tyler. I'm a former deep tech nerd. Now I speak business and market. And I work in buildings of the future at Velux within Radical Innovation. So we're looking at, amongst other things, decarbonizing the built environment, increasing the energy efficiency of buildings. I have sort of a passion and interest in startups, and I enjoy living and working in a corporate, but I also enjoy the pace of startups. So that for me is one of the more exciting things, the ability to identify meaningful problems and bring fast solutions. And then one of the things I try to work on a lot in my sort of day-to-day work of magic making is creating the space and the mandate to do fast startup collaborations and try to drive results on a startup pace and maybe not a more traditional building industry pace.
Okay, that's great. And now we know a little bit more about you. Actually, let's just quickly maybe add a little bit of biographical data. Niels, just give us a little bit a flavor for how did you end up basically standing here today?
How?
By train?
By train or what? I took my electrical car.
By electrical car, yeah. Okay. So, I mean, more from the point of view, you work at Covi and on a day-to-day basis.
All right, so we have worked with this startup program. We are also a friend of the house here. And I think it's super important. I mean, I cannot just stay in Covi and invent the new future. So that's why we're here, and also why we also want to be here all the time.
Nice and concise answer. Thank you, Tia.
Yeah, so the reason why we're here and doing the collaboration with you is so that we can really complement each other. Because obviously, as it has been said, there are certain advantages to being a startup in regards to agility. We have a lot of contact with customers, etc. But if you have, I don't know, larger muscles or what you want to say, you might have more in-depth experience in regards to competences that we haven't hired yet because we're only 16 full-time employees.
Right, so what you're saying is that basically, back to Ole's prompt here, there are plenty of reasons to innovate and not necessarily just innovate on your own, actually work with other people. So it's about collaborating across the ecosystem. Ole, how did you end up standing here today?
I'm actually by bike today, no, I'm standing here because in Contact Lab we tried to push the traditional building industry to become a little bit more innovative, to become a little more digital, in order to become more productive and more sustainable. So we are making projects to challenge the understanding in technology, and of course we try to bring in startups to try to bring in tech companies to help with that.
That's great. And if you just tuned in on the live stream, we're basically at the AEC Hackathon, the 2025 AEC Hackathon, and we're basically looking at concrete steps towards net zero, and within that, looking at collaborations between startups and corporates, and basically broader across the ecosystem. And just before we get into the questions, and we're going to be working through them quite fast, I want to encourage anybody online or indeed in the room to think their own that they might want to ask our expert here, our experts. And also, it should be said, the slides are probably available afterwards. And of course, I'm sure Molius modenhedsmåling has a term in English, and that will be available if you search online.
Yes, definitely.
Excellent. All right. Let's start with the first question, which is, how do we use technology to decarbonize construction? And if you could give a concrete sort of hands off of the pockets, like hands-on answer, that would be super helpful. I don't know who wants to start.
I can go. Yeah. So I think data is super essential in order to actually figure if you're doing something better than before. Yeah. So we have a range of tools where we kind of like make sure very early that we can already, when we're just sitting conceptually designing, understand, are we actually making a real change, or we just think we're choosing nicer materials? Okay,
so data, and clean, sorted data.
Yeah, and also something that you can actually compare, right? You don't want to, it's not just data, it's good data.
It's good data. All right, great. Any other takes on concrete steps?
Similar to Niels, you can't measure, you can't improve what you don't measure. We're currently working with 5 of the biggest Danish contractors, Peel, MT Højgaard, Orslaf, and the like, in implementing methods and technology on their construction projects in order to be able to measure energy consumption, because that is actually going to be a requirement to be able to document that from this summer.
Okay, so you're now hinting at basically what's called regulation to an extent, both yes. Danish, maybe EU regulation in this particular case, right? And any particular thoughts on what's happening here?
Yeah, I mean it's nice that Denmark is so ambitious on that agenda because. Everything shows that the construction will only move if there's a requirement, either from clients or from regulation.
Right. And if you were to look at one specific challenge that's kind of a roadblock for you, what would you kind of, if you were to literally visualize it in front of you in basically getting towards net zero, each of you, what would be a practical example?
So talking about regulation, prior to me jumping to Ento a year ago, I worked for the Danish government. Where we did this analysis that identified, I believe it was, that Danish regions and municipalities are currently wasting 630 million kroner per year because they can't get access to their own water and district heating data. Wow. It's 500 million kroner a year that we could get tax cuts if you want to have that, or we could spend it on Greenland or the defense, or get cancer treatment, etc., etc. Like, there are so many cases of how we can use this data But increasing the speed of the data that is available in most cases is just meter data, main meter data that is already there, getting faster access to it. And then you can talk about data quality, data transparency, documentation, etc. But first step for us is just getting hands on the data, and then we can work with what we have, and there's so much value in that. And I have cases of that if you're curious.
Well, let's have one, just one.
Just one. So let's talk about a running toilet. How much water do you think that wastes? So we worked for a couple of months to get access to water data for a Danish municipality. We're helping about 30% of Danish municipalities. They're paying customers of ours. And it took 10 months for me to wrestle data out of the meter company, although we had everything signed in regards to GDPR and consent and etc. Finally get access to the data, I onboard the data, boom, instantly we can see that a running toilet in a building that's not used, because we're dealing with large building portfolios here, so it wasn't noticed. It was wasting 500 liters of water an hour, which is 1,000 krona per day, which over 10 months is 300,000 krona. And you can probably, I don't know, get extra hands out in that municipality for that, or the municipalities also have to save money, so they have to run fast, and it's kind of the chicken and egg as we talked about. There are all these cases of how we can quickly fix a running toilet. It takes 5 minutes, if you know what you're doing. But it's not prioritized because there is not enough time and resources for it. And it's just too bad. Hence the 500 million kroner.
Great, that's a really good example. And as the old saying goes, a billion here, a billion there. Sooner or later, you have real money. And basically, let's basically sum up. So the key point of the challenge that's standing in the way, I'm hearing, is access to data and time and prioritization to an extent. Is that also true?
Yeah, but if you have quicker access to data, then you don't have to spend 10 months getting access to it, right? And that's resources as well. And I think that's one of the reasons why I'm hired, to hunt this data and not give up. And it's just too bad because it exists. I set up SFTPs and then we integrate with that. We can do that in 15 minutes with Kamstrup Reedy, for instance.
Right.
So the utilities also don't have to spend a lot of time on that. But there is actually an API that we could just integrate with if the metering company would allow us, and we're happy to pay for it.
Most of our audience, of course, is PhD level and so on, but we might just need a little acronym cruncher there. So SFTP and API.
It's basically a save server. Yeah, that I then create for them. So it's like a folder at Amazon where we then put the data in, and then I can put it where it needs to go, a data source.
Secure file transfer protocol, if I'm not mistaken. And then the API, how would you bring that home for, just in case somebody's mum is, or dad, or 4-year-old son is watching this, right?
Of an API, kind of like when you're out at a restaurant and you want to order something. The API is kind of like the waiter that's going in between you. You place your order, it goes to the kitchen, fetches the food or the data, brings it back to me. And then you can call it, and it will give you, hopefully, what you want if you set it up correctly in regards to the documentation.
Right, with the dressing on the side. That's great.
If that's what you prefer.
If that's what you want.
But you have to tell it, right?
That's a very good analogy. That's really helpful. Thank you for that.
You're welcome.
What about other practical things? So we've established data. I'm not seeing any, severe disagreement here from either of you three. Do you have something else that's standing in the way for making this transition? Niels?
I think I just saw very briefly, I don't think you all managed to mention it, but one of the challenges was that customers don't ask for it.
Yeah.
We were discussing it right before, right? You have a solution, you could find 5 to 20% in any organization you come into, more or less. So why don't everybody ask for it? That's a little bit peculiar, right? Because that would be a natural thing to do, but there's just so many agendas for a large construction owner.
Yeah.
And that's kind of like the challenge, that they don't have time basically to focus on this as well, because it does sound a little bit complicated with APIs and stuff like that. So can they actually do that?
Yeah.
So I think understanding that technology here is actually more accessible than they think is super essential.
I think that if I could maybe compliment it, so I love the measure or the survey from Molio, which looks at the construction sector at PropTech Denmark. We do one specifically for real estate, which is basically the buildings are already built, right? And there's some overlap, but there's also quite a lot of difference in culture and approach and so on. And what we're seeing in our annual measurements there is time as a priority, but also that people used to work on what you would, using a German term, work on Gefühl, right? They would basically kind of like, feels right, this seems good. and we're basically seeing a shift where people are starting to use data. So it's also a question of maturity to an extent, of people realizing that it can be available and then wanting to interrogate it. But there's definitely some way to go. What other barriers?
No, I mean I want to draw a little bit on the same barriers. I completely agree with Niels, but I think there's also something that points back at us and not. In not being good enough to translate business problems to data problems, to technology problems, or to technology solutions. And I think a client might not shouldn't ask for data, but actually should come to you with his business problem, and then we should try to solve that together. But also there, I think we definitely can improve.
So there's also an element of strategic thinking, basically. That's kind of what I'm hearing from you.
Yes, and not putting off all the technology problems and acronyms on people that are not used to it.
Yeah. That's great. Tyler?
Yeah, I was going to say, I think one of the things I encounter is we're now looking at traditional problems with additional dimensions. So you might be talking about, is it embedded carbon? Is it possible for circularity? Is it extended life? You need data to make good decisions on that, right? You need the LCAs, you need the carbon footprints. That's a whole, ball of worms. But to zoom out a little bit, I think on what's interesting is you're now adding different dimensions of requirement, different dimensions of consideration. And I think part of the challenge there is also, how do you learn enough about that to zoom out and think smart about it? Mm-hmm. If you add a carbon footprint requirement, okay, now we have this carbon footprint requirement, and you zoom in on that, you may actually be creating problems that are going to impact other metrics that are not currently on your list of requirements. So getting the data allows you to be able to target things wisely, but for me, it's also pushing a little bit more on the envelope. What can you see coming on the horizon that will make a much more holistic and wise solution to how we work with?
Could you come with a concrete example from your world?
I mean, a concrete example is like, we look at a laundry list of carbon footprints and say, okay, this carbon footprint for this material, now we're going to make these responses by tweaking it around, and then you get a little deeper, and we have a lot of carbon footprint specialists, right? You say, but that's actually an industry average number that we've based all of this on. Now we work with our partners to actually get specific supplier data. Right. And that specific supplier data lived somewhere in that industry average, but it might actually be living in a place that no longer motivates you to target that material. You might say, oh my God, like glass is just abysmal. Right. Glass does have a high carbon footprint, but and then you make decisions based on that, and then you roll out more data and find out, oh, we've been pivoting in the wrong way. Or if you look at what are the most circular materials and then really get geeky into, okay, great, you can recycle an aluminum, but if the aluminum has certain impurities in it, you may not actually get back exactly what you wanted. Can you use that different form? Can you design that product so when it gets chewed back up and recreated, that it's able to go right back into the same requirement?
So what
all of those are detailed data.
Are inviting us into is a world of paradox and potential confusion there. But can you just help us quickly? Again, super clever audience here. I'm sure they've got LCA right down. But just in case they need to explain that to us. Life cycle
analysis. It's not my jam, and I should have not done the acronym soup. Life cycle analysis. So it's basically you're trying to understand what is that material, how is it born, how does it live, how does it die?
Yeah.
How do you create that into a bit of a loop?
Great.
And the carbon footprint, hopefully that's a little more clear, but that's how much carbon you spit out into the world making something.
Yeah, or embody, basically. Yeah. That's really helpful. Thank you for that. We're basically, if you are tuning in now online, we're about halfway point with this expert panel, talking about net zero and the road towards it, and basically the obstacles, and also about collaboration between startups and corporates and the ecosystem more widely. We're keen to get some questions. I know Torben has a question for sure, but before we get to him, any other here in the room that would like to ask a question for the panel?
Pablo from Builders AI. A few of us are coming from hackathons down in like Switzerland and Germany. The open source construction folks. I don't know if you know them. Curious what your thoughts are about open source, as a technology trend? Is it on your guys' radar in the industry up here? When you talk about like data access, one of the problems is the software that accesses the data can be a chore to write. It can be complicated, filled with bugs, especially for data sources that people aren't maybe not familiar with, API access. Where do you think strategically about open source, open standards? IFC, there's this whole thing going on in the AEC industry about IFC adoption, even next generation, IFC 5 working group is happening. Any of these things, any comment about how this folds into your plans?
So let's just quickly do the terms. IFC.
IFC, Industry Foundation classes, standard for BIM building information model.
All right, so we are talking about standards, so BIM, building information management modeling, and then what's it called, IFC as well. Would somebody care to comment basically on the move of?
I mean, that was a broad spectrum of of things to comment on. In general terms, I think the Danish industry is very what's called much in support of especially of open standards. Long tradition of IFC. There are many projects that work in IFC here and have been doing so for the last 15 or 20 years. I think Niels has been doing one of the first IFC's projects in Denmark when we were in Rambøll together many years ago. So IFC is a solid basis. We actually tried our first open source software, also Niels and I and a few others here a couple of years ago, an LCA tool where we tried to exchange. It was difficult to motivate the industry to go into an open source project. So it actually failed, or we lost patience, or something. I think everybody likes the idea of open source, but the consequence of open source that actually somebody needs to do the work is is as so often the challenge in that.
I think.
It's publishing. The idea was publishing open source. I think using open source is happening to a much larger degree, but the idea was to publish an open source LCA tool.
All right, great. And actually yesterday from this stage we had a panel from the Computational Design Network and AEC Hackathon talking about actually open source and so on. So if you are online, you can maybe go back in the archive. I think the recordings are available. But just a quick test here. Who actually uses open source software in this? And now extend it to who knowingly knows it, because you might actually be using open source software without realizing it, right? Who has a GitHub account here? Yeah, Ola definitely. Okay, great. And who actually actively contributes towards open source software development? Okay, so we have the hardcore crew just there. That's great. All right, any more questions?
I think just an add one to that one, because we had a discussion in an industry forum the other day, and with all these AI engines, right? They're great, but they're super expensive, and you're also a little bit concerned about what's going to happen geopolitically, so on. So open source AI engines are actually, I think, super interesting, because normally our corporate IT organizations, they don't really enjoy open source. It's a lot of manual implementation and operation. But here, there's also a resilience challenge. And I think that's going to push that agenda quite a lot in the coming years, especially with these AI engines. So I think that's going to be quite interesting. And I think if you first start with an open source AI engine, you would also most likely add more open source on top of that. So I think there's going to be a move to that now, which we would not have seen otherwise.
Yeah, I have to admit, as a past, way back in the previous life, business owner of both corporate IT and open source software applications roll out across 50,000 employees, I can tell you there was open warfare between those two teams, because the mindset and ethos differ quite significantly. Let's have a quick question from Torben.
Well, thanks. First of all, thanks for telling me that I have a question, Michael. But a quick reflection and then a question, primarily for you, Tia. But the reflection was, as you may know, I'm in charge of the AEC Hackathon here in BloxHub, and I think for next year's challenge, we should come up with a challenge saying, develop a tech dictionary, because your definition of what is an API to a restaurant and a waiter, that was cool. That was really great stuff. And LCA, etc. everyday language for general people, etc. So there might be a need for sort of an online tech dictionary. That was the reflection. The question, it's not sort of a very tech nerdy question, but it opens up the question of competences at municipality level, and it may be more or less is towards you, Tia, because imagine that you being sort of the HR manager in a medium-sized municipality, how would you ramp up the competencies on their side in order for them to talk to you eye to eye on the tech issues, on access issues, on APIs, etc., etc.? Because I feel that the great challenge is to push this CO2 neutrality to municipality level. And watching your website, you have lots of different municipalities, as you just said. I was born in Aalborg, living in London, so Aalborg and London on your website. full account for that, so thank you so much. But, you know, just imagine the competence development on the municipality side, on technical improvements, on the utility companies, etc., etc. What is needed at municipality level to match the competencies in your company and in Covi and Velux, etc., etc.?
Thank you for your question. It's a great question. I don't think that it's so much that we need to match each other one-to-one. I think in this diverse and fantastic world that we live in, we're different and we can complement each other and we can work together, right? So also in regards to what you were saying before, I think we're all at different maturity levels in regards to resources and how much of a deep dive you can do on a strategic level and really nerd into all these fantastic terms. Or if you're really just super busy because you have to save 2% every year at a municipal level. So what I have always said to Danish municipalities that I have worked a lot with in my previous job as well is just to get started. Don't let the perfect be the enemy of the good, right? Don't feel overwhelmed. Even small steps can really make a big difference. And we see that a lot. I have personally worked in, I think it's 3 to 4 municipalities myself in my previous life. So I know about the, dare I say, bureaucratic organization, especially of the larger ones. And it hurts my heart, honestly, that it's slowing down the pace of how we can use data and tools that are already available because of compliance, etc., where you maybe start too big instead of just working together. You know, one of my first meetings when I joined Ento was to go to a Danish municipality, not mentioning any names, but we got access to data with our wonderful data hub that we have for electricity here in Denmark. 5 minutes from signing up automatically. We had everything onboarded with sites, everything, run the analysis, and we could see that just one of the alarms in one of the buildings that something had broken, and it was costing them, just in the first 3 months of the year, it had cost them 150,000 kroner, which would then go on throughout the rest of the year, and then they could fix it. And then that it was a school building, they could do something else. And that's a free trial, you know? So let's just get started, you know? And then you can always, you know, man up and you know, get going. But if we can't collaborate because of something in regards to compliance, let's not waste that money in CO2. Like, that's just not. Yeah.
All right. Does that answer the question? So basically, even a journey of 1,000 miles starts with the first step. I think there's an old proverb to that. So we should be singing basically, there's an old Scottish song, which is I will walk 500 miles, something along those lines, and get into it. So so you basically shared one of the tips for basically collaborating across silos, quite frankly, which is basically inspiring people to take that first step. If you were to share a thing that you wish you had known before you started working outside your silo, Tyler, what would that be?
How hard it is to simply explain in a simple and compelling way that resonates to the person you're talking to about something that you are ridiculously nerdy about.
Right.
You know, we talked about this yesterday, this concept of elevator pitch, and how I used to think I was good at it. Maybe it's that whole cycle. You think you're really good, and then you realize you're like, oh man, I'm really actually not so good at this. But you're triggering me a little bit. Like, how do you how do you get that hook in? How do you communicate this wonderful technical solution that you have?
Right.
One of the painful things I've realized through my work in the last, say, decade, no one really cares how it works. They don't, the electrons and the ions moving around and all that. They're like, I'm gonna go get a cocktail. But if you can take it to what does it do, and what does it do for me, and how does it actually resonate in the things that I need to get done? So for you, cash money. Let us work with you. There's actually all sorts of low-hanging cash money fruit. We can pull this off. That interpreter, that way to connect to diverse is one of the things that's just been awesome, talking to all the last people in the last day or so, all the different angles people come from,
right,
and practicing getting that simple hook, getting that conversation that opens and starts flowing, instead of having people check out.
Great. And actually, that's a great ad for immediately after this session. There'll be a short break, and then we'll actually have some speed mentoring. So stick around if you want to experience that. It's going to be fast-paced and quite interesting, and actually lean into exactly some of those. And actually, you're one of the mentors, so you'll be here. Nils, what's the key thing you wish you had known before you got into basically working much more broadly than perhaps you had imagined when you just graduated back in the day?
Well, I think what Tyler was saying, like, this is about communication, right? I'm an engineer. So when I present a new idea, I'll start to say, okay, this is how I'm gonna fix it. So I totally forgot to say what I'm gonna fix and why should I fix it and stuff like that. And I can just see our new engineers coming in super enthusiastic with an idea, and they just deep dive into that whole of what am I gonna do. So I think that's also for the AEC Hackathon participants. Like, you can fix a lot of problems in the world, but if you can't get people to understand what you actually try to fix and why you should fix it, you're gonna have a hard time, and it's gonna be very disappointing if you don't. So that was my learning. Now I always start with Simon Sinek, like why, what, how. Always start with the why. I really enjoy that, and it's really old, but it still works really well.
That's really good. And actually, just kind of tying them all together, what you're basically saying is there's cash is often one that people can relate to, but actually what you actually dig into is a deep human need for loss avoidance, right? So and if you can explain to what it is you're fixing, that becomes more apparent and clear. So Ole, from your point of view, what do you wish you had known before you got into all of that?
I mean, I think all the good ones are taken. Actually, I mean that's that's the obvious one. I think one thing that I mean, I'm also a guy who likes to work with new technology and new ideas and everything. I think what puzzles me currently is this implementation thing. How do we get the things to live? How do we get things to be broadly used? Go from 10 people or 100 people using it to many people using it. And not that I have a learning on that one yet. Except, I mean, you just need to be going. You need to stick to something. I think for us as a community, and that's the important thing to learn, is how do we scale all the good ideas that we are that we are having. And
great. That's going to be an enduring question, and part of what will be answered, I guess, tomorrow when the hackathon rolls towards the end, and we get to see some of the solutions that people have been working on. Now, in the audience, any more questions here for this expert panel? Maybe here from the front row. Reluctant? Oh, we got one from the back row. Saved by the bell.
I have a question to Ento. Do you have solutions to track indoor quality data? For example, daylight level, temperature, humidity, acoustic quality, and indoor air quality.
So I actually don't know. I'm only here because Melde had to take care of his child today. So I don't know how much I'm allowed to say in this regard, but yes. And we're working on something very exciting in that regard because there is a large potential. So, but I can say this, that there are 3 tricks to our pony, right? So we have analysis of the building portfolio. That's the time series analysis, and then how you can energy optimize across the 4 different, electricity, water, district heating, and gas. Then we have control, where we use, for instance, ECL data, Danfoss lean heat. We integrate with that, and then we can take over control in the rooms For instance, we have a lot of daycares where we want to keep the temperatures right and the indoor quality right, so that they have a good learning environment, etc. So we have that, and then we have strategy, which is like long term. How can you reach your targets and all of that? Yes, so we have a lot in that regard. Yeah, but I'm happy to get back to you, and I'm sure Melody will also distribute further details. But we're doing some very interesting work on this right now.
Watch this space, basically, what you're saying. But I'm just going to turn to, I think if I say fresh air and daylight, I think of you, Tyler. So why is it I think of that? Could you say something more about fresh air and daylight?
Yeah, I don't know. It's a Velux thing, apparently. Daylight and fresh air. I will say, I don't know if it's related to circular, but as an American who has lived in many spaces which are surprisingly dark, crowded, no fresh air, not connected to the outside, and then you come work for a company that is obsessed with daylight and fresh air, you feel so much different, right? It's a mental health thing, it's a physical health thing. And it's interesting you talk about data for that, because I was thinking yesterday, like, how do you quantify that? And how do you do that in a way that's compelling and powerful? Like, I know when I look at glass, I look at it in a way that I understand no one else does, because I'm broken like that. But how do you really, like, here's a specific example. You go into a crowded meeting room and you start having a high-powered discussion, and 7 minutes in, your brain is broken, and all you're thinking about is like, when can I get out of this room? And you have 53 more minutes of meeting. Well, the CO2 in that room has gone through the roof, but you don't understand that until your eyes are open to it. And then you start to say, oh my God, this is so stale in here. Can we open a window? Or a colleague comes in and walks in and says, this room needs some improvement. Let's get some fresh air in here. Driving that to a conscious awareness in more people will then call for a higher awareness of that, a higher demand for that, and I think bring a higher quality of life. Maybe I know it's a corporate line from Velux, full disclosure here, but I'm a big fan, actually.
Yeah, just briefly too.
Yeah, so briefly, so we're in Copenhagen right now, and a couple years ago they did an analysis with HUFOR, which is the big district heating and water utility, and Danfoss where they looked at flexibility services. And they found out that indoor air quality can actually be a driving factor in getting better access to building data and working more effectively with the buildings. And this also was a question, from before, how can we get the municipalities, also the bigger ones, to work more actively with the data here? So they're political organizations, right? And something that they really care about is welfare. How good are you feeling when you're in different rooms?
Yeah.
So for me, one of the reasons why working with digitalizing buildings is so fantastic is because there's such a big potential to get it moving in this regard. And this is something that voters care about, that when you hand off your child to daycare, that the building will also take good care of it. And it's happening automatically so that the busy personnel out in the buildings can take care of what they do better as humans. And then the AI can do what it does better and free up more resources. So I think indoor air quality is super important to working more effectively and cutting through some of the red tape, also in public regards. And of course, private sector, it's moving ahead. Yeah.
So it's a really good question, and we're going to dive into it a little bit more, because I'm actually going to ask for practical examples of some of the things that we've just looked at. But I'll just quickly add a couple of quick footnotes, because it is an important topic. It should be mentioned maybe that COVI and actually Velux through the Urban Tech Accelerator did a trial where they were looking at not just the indoor air quality, but also there are times of the day when in Copenhagen it's actually better not to open the window, unfortunately, because air quality isn't always better outside. And if I'm not mistaken, be careful now, I think it was with Climate, a startup that specializes in indoor air quality. And I'm excited that Into is also coming out with something, because this is a market that is massive. So there's room for all the different solutions out there, whether it's Climate, Climify, and Into, and so on. It should also be said that Realdania has done a lot of work around indoor air quality in schools, especially. So if this is a passion point for you, maybe search for some of their reports. It is really worthwhile, and it should be said that some institutional air is not fit to be breathing. That's a safe statement. We're kind of coming up towards the final stretch here. We have time for maybe one more question from the audience. I'm particularly keen for the front row to get a little bit more engaged. Normally, they're the ones that are top of the class, right? That's at least my experience. But just can we? I mentioned a couple of practical solutions out there, right? Do you have some others in the broader topic of decarbonization that you turn to, either you see as a role model or maybe a tool that you're using in your work that you could share? Because that will help people kind of, again, get concrete look at what are practical steps. Tyler, do you want to start with sharing one?
Concrete example? No.
No.
No, I don't know that I can share a concrete example. I will share an inspiration, though.
Yeah.
And it's I like to think that future-proof buildings, they need to be more like nurturing organisms. They need to be dynamic. They need to provide beautiful spaces to live in that are energy efficient, that are comfortable. And so, and they also need to have a whole life of their own, right? Through ups and downs and rebirths. So that's actually my vision for tying in a sustainable circular build environment, is at the same time we up the game to really provide this human experience that is enchanting and healthy.
So there's basically a call to action there. Niels, any?
Yeah, so what we've done for some large organizations now is to kind of like make an energy strategy with them. How do they decrease their energy usage and hence carbon over time? But it's first when we get something like INTO or similar solution is in place where we can actually prove, wow, how big a change it actually delivers. Then they get really motivated. So that's really, and we have, I can't say it, but very large industry organizations in Denmark have started to go that way. And I think that's super interesting to see the motivation when they see the numbers. They like PowerPoints, but they like numbers much better. So I think that's a really good example.
And there's also an implicit tip there to anybody working together with others. Don't forget the numbers, right?
Exactly.
Yeah. Thea, do you need more examples?
Yeah, so I think I've covered electricity, water, so maybe a district heating concrete example in that regard. So we can integrate with comes to really in 15 minutes, 10 minutes if we're fast. And then we can run the analysis and everything is good. This means that we can be truly data-driven. We can use data as a tool to work smarter, not harder, which is fantastic. Make life easier for the building managers. So we were talking about district heating data before. So I don't know, do you ever look at your radiator in a room? I just had an issue with mine. I don't know what it's called in English, but I had to change my packdose because the hot water was just running through it, probably like 90 degrees, almost boiling, which is terrible because then we might be buying coal or whatever to heat up all the water, make it go all the way to the building, and we're not using the energy. That's waste because the return temperature is way too high. So if you actually get the data on, you run the AI, you can identify there are some issues in this building, you can go and fix it in 5 minutes. But most people, they can't even read their bill and they don't have access to data, they don't have the AI. So they might be paying like a really high penalty on that because that's what the district heating companies do to incentivize the customers to fix if something is wrong with the heaters, etc. And that's, you know, in most cases, that's several 100,000 kroner, you know, that can just be fixed in 5 minutes. So let's go do it.
Let's go
Start
do
small.
Ole?
I mean, I had some time to think about it. Didn't come up with a super good idea, but I think I want to. You mentioned it also. I want to just praise a little bit all the publicly available data we have in Denmark, which actually is a great thing. Also, if we kick it a little bit to our neighbors in the south, who doesn't have it, and all the stuff that is being built on that energy data as one example. Since yesterday, my Clever app from charging my car actually talks to my car and knows how much it needs to be charged and can pick the most optimal point in time that can be used. And all these small things can actually be done because we have smart meters, because we have this data, and because it's so available.
Great. Okay, I'll throw one in. Ehrlich, it's an unusual air quality modulator, so to speak. It's fitted on top of a roof. It's one of our long-standing members. They've just entered up a collaboration with DTU and DS, and they're specifically basically taking less air in from the outside, but instead actually sanitizing the air, so to speak. It's going through like a plasma thing. I'm not a engineer in that field, so you would have to ask them directly. But it's just the point I want to drive home with it is that there are many different angles to looking at this. The drawback with it is that it can only be used on certain types of buildings where there is a natural intake from time to time through opening of doors and windows and so on. But the point is there are many opportunities to try and address these challenges. And the key thing I'm hearing from this panel as we start wrapping up is basically data, and work across basically and find ways to communicate. Is that a reasonable summary? We have time for maybe one last question before we get a call to action from all of you. Mauritius? Yeah.
Hi, my name is Mauritius. So I'm designing new neighborhoods, so doing master planning, and then also I'm a housing geek, so trying to figure out how to make better housing at a lower price. So I guess that's it. We all talk a lot in urban planning about how to fix cities, but I guess that a lot of times when we're starting from scratch, like designing a whole neighborhood, there is a wide array of solutions. In prop tech, in all sorts of things, but actually we don't have the right argument or the way to reach out with you guys. Okay, so the question is, how would you think that your expertise could be more easily, more seamlessly inserted into the planning process?
All right. Okay. So that's basically how can you be drawn on in the planning process, which is actually a quite lead over to a variant of the question of what's the immediate next step for basically this group here. Tyler?
I don't know.
Yeah, that's a fair answer.
I'm an ideal user. How's that?
Niels?
I think because we have been discussing that historical data should be the key to everything. Then we're going to get AI to tell you exactly how the next neighborhood should look like, right? But we just don't see it like that because we also did a lot of mistakes in the past, so we don't want to replicate that. So I think it's a combination of respecting the past, looking at what worked and what didn't work, but also having tools that can help you show the scenarios of what will happen if you do a neighborhood like this and this. So we've gone a little bit away from just saying historical data will fix it all, to now saying we need a combination of knowing what's good, but also being able to simulate what will happen. And I think with AI and stuff like that, you can simulate much more of how people will feel and experience stuff than just hard numbers.
Right, and then just to tie a super practical example, Icelandic startup called Treble, incidentally, I think Compass has invested in them, can simulate the acoustics of a building. So a way of letting you experience the space before you actually change it, or variants
They were actually
of it.
part of our startup last year.
There you go. Yes, great. And actually an Open Tech alumni. There you go. Full ding ding ding. Tia, any suggestions for how can you be part of this process, basically?
Yeah, so I always think it's great to have a lot of users in the conversation and then to test and iterate all the time, right? Because we can have a lot of hypotheses about what would be the best way to organize a city, a building, etc. But actually front-loading the information from the users, I think is just key. Because it's people who drive change and they will make life very hard for you if they're not happy. We've seen that in a lot of cases. So yeah, just bring the users in.
Okay, so front load, test and iterate. That's really helpful. Ole, any thoughts?
I mean, I wouldn't involve me personally in urban planning. It will be very much square and very effective. But I actually want to draw a little bit on what you are saying. But what I hope to see is what we use technology for is to enable users, people living there, to get them much more involved into the design process, both for feedback, but maybe actually also for try to visualize and test their own ideas, and to have a much more community building into building areas, into urban planning.
Great, and as they say in academia, more research needed, right? So I think we just booked you for a panel another time, which is looking at basically neo-brutalism and brutalism. Was it effective? But we'll leave that for another time. We're going to start rounding up here. You are basically tuning in from around the world and in the room to the AEC Hackathon Tech Talks this Saturday, beautiful afternoon with the sun shining and a blue sky outside, and in here lots of hackers working away, and our experts, Tyler from Velux, Nils from Covi, Thea from Into, and of course the one and only Ole from Contact Lab. The last word that you will get, and we'll start in this direction here, is basically what's one call to action. What would you like the people in this room to do next, or what would you like the people watching from afar to do next?
I mean, drawing on the data agenda, use look for more data. Look into how you can use data to improve your whatever you're working with.
Great, Thea.
Yeah, reach out to anyone that you would like to collaborate and just get started.
Yeah, just get started.
Yeah.
Nils.
And then I've talked about before, like make sure that you actually make an understanding of what you're trying to fix with your partners.
Yes, that's great. And last but not least, Tyler, you get the final word.
Have fun, dream big, make lots of friends, refine your ideas.
All right, and that is close to the Road to Next Zero panel. Thank you so much. We will now take a brief 10-minute break. There'll be a slightly longer break in the live stream. We'll be back here for some speed mentoring, so do stick around for that. But before we close out entirely, I'm going to hand it back to the one and only Aske.
Thank you to the one and only Michael, and thank you guys a lot for joining us today. So yes, as you just briefly mentioned, we'll have a short break, guys. Don't go too far away. Join back, and we will actually have PropTech Denmark with Michael on stage again for a one-on-one mentoring session soon. So stay tuned for that. Go get some coffee now, and thank you a lot for your attention and for your participation. Thank you, guys.
Thank you.
Once again, Michael, thanks a lot. You have been working really hard to help us do this this beginning of the Tech Talk program. 1 2 1 2 mic check. Yeah. So, and could I get the program on, Mark? We are ready to continue this day's stream, and we'll be online again. And with the program on the screen here, we see that now is the point in time to introduce the Tech Talk by RIB Software. We have Matthew Jackson coming up here, and he will be on his way. So as out of that, we have had a mentoring session, and we have had the panel debate running, and a lot of inspirational things has been applied to the knowledge of all of you. Does any of you have any reflections in regards of what did come up so far? Maybe you, Matthew, did you have a good mentoring session?
Apparently. I mean, I learned something as well, which was quite nice. So that was great.
Awesome. Let's just take a second and plug you in here. After that, Henning Larsen is on board. We have Dalux, our new partner in the Partner Collective, coming up at 3:20. And Christopher Digens, live from Blockshop, arriving from Canada with the Tech Talk from Era 3D. And last but not least, a podcast actually also hosted by you, Matthew.
It is.
So it's going to be really exciting.
Good. You good?
Thank you.
Thank you. Good afternoon, everybody. And yeah, that works. Yes. Fantastic. Thank you. So I'm the first on, and there's probably people online, but not many people here. But it's still quite nice to just to talk. So thank you very much, Esker, for introducing me, and thank you very much, Blockshub, AEC Hackathon, all that lovely general thank yous. I'm Matthew. I'm British. I live in Sweden, work for a Danish company, which is headquartered in Germany, owned by a French company. It's a fantastic mix and total screw up of everything. So I work for RIB. I also run my own little charity on carbon education for construction, which is the podcast later, which we'll see. And I also held a seat on the now defunct. We defuncted this group end of last year at Building Smart around sustainability strategy. We wrote a white paper on how we will use IFC 5 specifically on building better strategic ways of managing sustainability. So when you talk to me about that, I can geek out. So I like to keep things really simple. I think this industry is way too complicated. And earlier we had the great panel standing here talking about APIs, and I think APIs are a very dangerous topic, which generally speaking is not understood very well by the general population that work in construction. There are a very small group of very smart people, mainly all of those people, who understand what an API is and how it works. I'm not one of those people. I know what it is. I have no frickin' idea how it works or how to use it. And I don't have a GitHub account. And I don't plan to get one because I'm just not smart enough to be fair. So I like to keep things simple. And I think that there is a situation where we will talk about counting now, we'll talk about technology, but it's about keeping it simple. So let's talk about some old challenges that we have in the industry, which we need to, I think, better understand. The industry doesn't really understand its own problems very well, to be fair. So we have the mass urbanization challenge. We just spoke a second ago about renovation. 80% of the buildings we need to renovate by 2050. And we're growing by about 1.5 million people per week from the countryside, rural areas, into urbanization. It's insane numbers. We are not that productive still. We discussed this yesterday. A lot of the challenges that were brought up for the hack discussed this. Productivity, how we get faster and better and more accurate at doing things. And this is, to be fair, this has been the common hack for all 6 years. It has not changed in my 6 years of doing the hackathon. And we need more money. I mean, the budgets that we need to go into capital expenditure in construction need to grow. We have energy transition due to the geopolitical tensions that we have, especially within Europe. We have Germany totally transitioning its energy from, oil from a certain provider into something much cleaner. So we're being forced to have these huge transitions, a lot of money, as well as huge amounts of money going into supporting the AI infrastructure that we basically need to do our jobs for the future. And there are new challenges coming as well. This one we always talk about as well, the lack of labor. Construction fundamentally is not cool. Sorry, I think it's cool. But if you go to university and you speak to non-engineering or construction students, you go to the computer science department, no one in computer science wants to come into construction. Really. They all want to go into other forms of higher paid, better well talked about industries. So therefore, we just have a huge shortage of people. Last year in the US, they only were able to fulfill 50% of their needed individuals. And it's not just people on site. Let me be clear. It's architects, it's engineers, it's estimators, it's project managers, it's BIM managers, it's everybody. We are short everywhere. We have a lot of technology and misunderstood AI. There was a discussion a couple of years ago here where we discussed how much of the technology exists today that we need to decarbonize construction. And we said 2 years ago, probably about 2/3 of the technology already exists. We're only missing 1/3. And that was before the big AI bubble appeared. So I'm pretty convinced that is probably racing towards a 70-80% completion rate. As it is, and again, a hugely common topic, of course, here is carbon counting. How do we actually count carbon properly and report it properly, which is a huge new challenge. But I think we can all quite honestly say, if you work in construction, we're busy. We are extraordinarily busy moving from one project to another project to another project. There is hardly any downtime for any individual, regardless of your role, between projects. Hardly any downtime at all, and most people work on multiple projects at the same time. I'm an architect by education. This is true. I never had a gap between projects. I was usually working on 2, maybe 3 projects at once, from a project on feasibility to a detailed project that has to be now delivered. There was no gap. So let's talk about what that means. We're busy. On average, 13 different companies are on a construction site at any one time, walking on top of each other, trying to get stuff done. On average, it's 13, right? And they have no idea what they're doing. They don't know, the electricians don't know what the plumbers are doing, the plumbers don't know what the HVAC guys are doing. There's concrete still being poured, windows being installed. It's a multi-phase, multi-issue problem. A fantastic PhD was written last year from Aalto University in Finland. They went on site and they studied humans for months in Finland and found that on a lot of cases, 80% of the working week gave no progress to the project. That is, imagine like if in any other industry that happened, like if Volkswagen was doing cars like that, like it'd be absolutely insane, right? So, and because of this kind of people walking on top of each other, 30% of the construction cycle is waste. It's wasted time, wasted money, wasted materials. It's around 30%. And if you think about that, 30% sounds quite arbitrary. If you think about if you're building 4 houses, if you were to build 4 houses, you would technically speaking throw one away. That is the easiest way that I can explain it in a kind of a more sort of down-to-earth sort of way. And again, going back to the Volkswagen example in manufacturing, it'd be Volkswagen would be destroying every 4th car they make due to the waste, right? It's kind of insane when you really think about it in that way. And as we know, 12% of all CO2 is produced from construction, new construction, so that's both linear and vertical, it's both. But if we just get rid of that mistake, right, those mistakes, maybe we could just save 1 to 2% of global CO2 just by not fucking things up. And I've used the swear word explicitly because it's kind of mad that it is that percentage and that high. So then I come back to this and I go, we're busy. Or, provocatively, are we just not productive enough and efficient enough as an industry to solve a lot of these problems? So, in the work that I do, in the company that I work for, but also in my other hat for my charity work, this is a big thing which I firmly 100% believe. We just have a complete lack of collaboration and coordination between all the different parties. And it's not that this isn't improving, this is getting a lot better. It is improving, but it's very slow progress. It's a big ship. Construction is a big ship that we have to move. And as I kind of said before, we need to do more with less. We need to build a shed load more housing. We need to refurbish a shed load of buildings. We have less people. We have expensive materials. And we need to use less carbon. So we are being asked to do a hell of a lot more, especially in housing, with basically less stuff to do it with. And if you have less stuff, we need to kind of really be better to understand what we need to count. Because this is a thing that we're also extremely poor at, is counting, which sounds quite arbitrary and quite odd a thing to say, but counting what we need to do, what we haven't done, and how we communicate that between ourselves. Because if we can't have people, the only gap to fill that productivity is tech. That's the only gap. The only way to fill is with tech. And the good thing for me working for a tech company, we have Dialogues here as well, we have Molio here, we have others, is that spending in tech is growing 3 to 4 times as much as the industry is growing. Although the industry is pretty flat right now, we're still growing a lot in our expenditure. So tech is our only fill. Because if we don't have people to throw at the problem, it's a technology answer. And what I kind of mean from a counting perspective, we need to be better at counting these 5 things. Money, time, materials, people, and carbon. Especially this one. This is the one I'm passionate about. But it's all of them because they all kind of have this very good interrelational work in the same way. And it's not just in one moment. It's consistently across all the different phases of construction. Pre-construction is a really funny one because a lot of people outside the industry assume, oh, architect designs something really beautiful, engineer will make sure that it stands up, then they'll go and give it to a builder that will build it, assuming it's this linear process. But most construction projects, unless you're building one singular house, the architect has not finished by the time you break ground. And now you're in a really interesting situation where you have not actually solved the design, let alone design, engineering, but you're already building a thing, right? Which is why you just have general cares, because these things take a long time. To build a hospital takes 5 years. To design a hospital takes at least 2, if not more, right? And I've designed a hospital. It takes a bloody long time to do. So living in a company of counting and communication is what I really kind of see myself as my day job. And we explain it a little bit like this. For any Zelda fans, I call it a Triforce because, you know, I'm a Zelda geek. Is we have this. So to control your time and cost, you need to think about the estimating and the control of that money long term. And again, this is communication between office, site, and all the subcontractors. On the quality and cost part, it's about scheduling in our mind. How do we accurately change the schedule to ensure that those 13 parties on site are not banging into each other? Time and quality is about the collaboration, understanding between ourselves the work that we're going to do. And if we can solve these things, something very interesting happens. We not only make the industry more profitable. Where's Covey? Covey needs to see this, right? By default, by a second step, we become more sustainable. Sustainability is not the goal. This is not the goal here. This goal is for profitability and efficiency. Sustainability actually comes, a lot of the sustainability in construction will come from solving the profitability and efficiency issue. The rest of sustainability in construction will just come from material choices. Low carbon concrete, low carbon steel, recycled materials, circularity, those sorts of things. That's a supply chain question. This 30% question, which is about 30%, is about ensuring a better delivered project. And by default, profitability and sustainability is your output. And quite simply, we call this the art of counting through technology, whether it's ours, whether it's somebody else's. It's the art of counting through technology. That's my little TED talk. Later on today, as part of my other hat, we'll be doing the podcast. We're having Torben, Ulla, and Niels on stage, and we will be talking about how Denmark should lead the world in sustainable construction. We'll be discussing later, and the pros and cons of what Denmark is doing, and how we can teach the rest of the world on how it should be done. Because Denmark, by far, in my opinion, is the furthest ahead in this field right now. So we're very, very lucky. If you want to follow me, here I am. If you want to learn more about my company, here I am. Any questions? And thank you very much. That's it. Done. Was that short? Yeah, 15 minutes. Boom.
So effective. So
Boom.
effective. Guys, is there any questions for Matthew from the audience? As I know him, he's fairly welcoming questions, so there is no trouble.
Means that everyone understood everything or understood nothing.
That's
There is no in between.
That's a high
at all
level of
whatsoever.
communication.
Yeah.
Okay, thank you, Matthew.
Thank you. Have a lovely day, everybody.
And right now we are actually scheduling for a short break again, a coffee break. So up until the next step, please grab something to drink and take care and relax a little bit. And we'll be online again soon. Thank you, guys. slowly with the Tech Talk program after a short break. So to everybody looking with us out there on YouTube, as you see, we still have some cool and exciting Tech Talk coming up and a podcast later. But first off, we're going to dive into inspirational Tech Talk together with Henning Larsen and Rampel. And Andreas, would you like to take it from here?
Yes, and you can hear me? We can hear you. Good. And can we get the slides up? Cool. So, the three of us from Ramble and Henning Larsen are going to talk about different projects where we do sustainability in practice. And these are the projects. Gulen is going to talk about urban heat islands. I'm going to talk a bit about energy modeling, which I can see I didn't update the slides there, so ignore that. And Katie is going to talk about digital fabrication. So I'll pass it on to you, Gulen, to start. Yep.
All right, I hope you can hear me. So I'm Gülin. I'm the Urban Heat Island PhD person at Henning Larsen. So I want to start my presentation by showing the big picture a little bit. So as everyone knows that air temperature is rising every year, and based on different carbon emission scenarios, we are actually shaping our climate legacy. And I know that all of you who are attending this event would like to pass a better climate conditions to the next generations. But unfortunately, today, cities are suffering from overheating during summer. And 30 and 50% of heat-related deaths are due to urban heat island effect. And this is happening actually while you're sleeping during night. But how about urban heat islands? And they are actually described as air temperature differences between city centers and non-urban areas. And this is happening due to three main reasons. The first one is material choices. Second one is 3D urban configurations. And the third one is lack of vegetation. But wait, there's more than one. And there are 4 types of urban heat islands, and this one, number 2, canopy layer urban heat island, is the most relevant one to do public health. And actually now I want to draw your attention on the fact that urban heat is actually dynamic. It's not the same everywhere and all the time. But how do we see them? I mean, what I mean? Actually, there are a lot of tools to observe different types of urban heat islands. I'm not going to dive into it, but today I would like to focus on this little one, private outdoor weather sensors. So there's a company called Netatmo. You may scan this QR code to access their weather map. Don't get me wrong, I'm not advertising this company. But the good thing is that there's a lot of outdoor weather sensors, and you can read air temperature data in real time, also historically. And I have collected 100 sensors, air temperature data for the hottest day of the last year in Copenhagen, and plotted them on an interactive map. As you can see on the screen, the good thing is that you can see a lot of hotspots. It's not good, but good for me because I'm doing the PhD. But there are many levels of hotspots. And I said urban heat is dynamic and it's changing in time. And you can see that the comparison of day and night of air temperature. So as you can see that there are some spots that they are popping out just only nighttime. So this is pretty cool actually to see the location of these hotspots. And before giving the floor to Andreas, I would like to say that as a next step, I would like to enlarge my data set in a sense of number of sensors and the period of time. And with this way, I will be able to understand this phenomena in a better way. And I also would like to identify the spots that are vulnerable to urban heat, and find, of course, a better solution to fix this. And also, this is not just about outdoors, also indoors. And floor is yours, Andreas. Thank you.
So a bit in the same area, we're talking about urban heat islands, future climate scenarios, looking into climate change and a warmer climate. That means something for how we model our energy models for buildings. These future conditions, how are they going to affect our buildings? Right now we are designing our buildings based on current weather data or even outdated weather data. So we're not really taking into account these future conditions where we expect temperatures to rise and humidity to increase as well. So we have to look into this when doing our energy models. We also expect the electricity to get a bit cleaner, but the demand for our electricity is going to skyrocket. So we have to take that into account as well. So with these changing conditions, we are seeing that some buildings risk being left stranded if they are not renovated and up to par with these future conditions. They can lose value. So we see a need to renovate these buildings to keep their value. So there's going to be this increased demand for renovation and energy optimization. So we are taking this a bit more holistic approach, where we try and take more parameters into account. But first of all, there's more data sources available out there than ever before. So we start out by collecting information about the existing building stock from various sources and get a good idea of the building before we even dive into the project. So we can actually show up to our clients well prepared and have a good idea of how they're building, what it is like and what the issues are with it. And then we can take our holistic approach to the energy simulation, where we don't only look into energy efficiency, but we also take into account indoor climate, future weather scenarios, so we can get resilient buildings, and even look at environmental impacts of the energy consumption of the building and so on. So to do this, we we try to set up a big solution space. So first of all, these different contexts, these different future climate scenarios of increasing heat. We have different kinds of passive interventions on the building envelope, for example. How much insulation do you put in, or different kinds of glazings. And we can also look at more active interventions to the systems of the building. So all these parameters set up a pretty huge solution space with almost millions of options. And to kind of boil that down to the essentials, we look into stochastic modeling. So a model or a sampling method like the Latin hypercube sampling method, for example, and for all the nerds. And what that means is this huge parameter spectrum or solution space can be boiled down to samples that explain the whole. So you don't have to simulate every single combination, but you can maybe simulate 5% of the whole solution space and still represent the general distribution. So we try to not let us like the amount of parameters, we can work with that with this stochastic modeling. We're not afraid of pushing the limits there. And then we look into different outcomes. So not just, as I said, the energy performance, but also how the daylight in the building is, the indoor climate, and then also operational and embodied carbon. So this is kind of what it looks like. We start by gathering these inputs. It can be data from Energistyrelsen, like energy label data, data from different GIS sources to kind of get the context of the building and model the building itself. Then we calibrate that model with all these different options and send a huge amount of energy models through pollination to a cloud computing platform, get all those results back, handle all that data, and we get a lot of different data points, as you see here, pull all this into a dashboard, which we call zebrafish, because apparently everything needs to be an animal these days when we talk about this. And the dashboard looks like this. And the reason we've done this dashboard is that it can be quite overwhelming with all these different options. So we've tried to simplify things so we can actually take the client in hand and show them different options, what they can play around with the tool themselves, and see, what happens if I choose. If I choose some different settings, it's going to narrow down the solution space to those options, and I can kind of see trends together with the client there. So yeah, we're trying to expand the amount of results over here. So, like for example, the embodied carbon module is not done yet, so it's something that we're working on. But yeah, starting with energy, moving towards indoor climate, and then carbon as well, trying to get that holistic view. Cool, Katie.
So, is this working? I don't know. Hi, I'm Katie. I'm another industrial PhD with Henning Larsen, and this is going to take a little bit of a shift because it's going to go a little bit less techy now. But my PhD is on additive manufacturing processes for architectural design. And I'm going to talk to you guys about one little aspect, which is about how we can think about integrating and how we can integrate digital fabrication into our design workflows as architects and what that means for our sustainability tools. Very briefly, so my PhD is doing quite a lot of stuff. So I'm doing experiments that look in design, into fabrication and evaluation, and everything in between and how they all connect. But yeah, like I said, I'm going to talk to you just about one little part of my research today. So I'm sure most of you know some sort of version of this diagram, the architectural design process. Generally, an architectural design process, we can imagine it as this linear stages, which increase our specificity. So we start off with a brief, we then have some conceptual stages, we then get into some design development, technical design. At some point along there, we're trying to integrate our sustainability considerations, and then we get on all the way to manufacturing, construction, and then handover. This model, it works really well for standard practices and design practices. However, when we want to integrate things like digital design or digital fabrication into our designs, then it gets a little bit more complicated. So at the moment, I look at 3D concrete printing, but we can also imagine this for multiple other digital fabrication options. But at the moment, how we're currently working and trying to integrate it, what we can find is even though our brief and our sort of early design stages are the same, what happens when we get to our design development is we start bringing in external contractors who are specialists in that digital fabrication. So 3D concrete printing contractors generally come in, and then they take over that design, the fabrication of the 3D concrete printed elements, and it becomes separated from our main architectural design processes. And this is great because they have the expertise, they have the knowledge, they can specify the materials, they specify the fabrication process and everything. But the challenge is that because it's being separated, then we're not actually as architects able to control and understand some of the benefits that the 3D concrete printing might be giving us to our designs. And it's also becoming separated from our digital design workflows. So we have our design process, right? It's sort of this linear phase of stages, but then we also know that as architects, we don't work in a linear way. We work in this very iterative, cyclical way of working. And I call these sort of digital design workflows. And the way that we're doing it now is we're actually leveraging the digital chain to try and shift information forwards. And this is really exciting. We've got lots of tools like letting us do this, probably tools that you guys know a lot more about than I do. And what's also, I think, is really exciting is that we're starting to see sustainability tools being introduced into this digital workflow. And we're actually managing to bring our sustainability tools earlier into the design process so that we can, from much earlier, start to actually be able to understand the environmental impacts of our designs. However, the problem is, because our digital fabrication, 3D concrete printing, is currently separate from this general digital design workflow, we're not really able to understand the impacts, and we can't take full advantage of the process. So 3D concrete printing, for instance, it has quite a complex set of constraints, which are like very highly dependent on the material and the fabrication process. And these two together, it basically determines whether something's going to be a successful print or not. It also determines a lot about our sustainability calculations and the environment, knowing the environmental impact. So if we have it, depending on what material you choose, it will completely change the environmental impact. So what I am sort of proposing, what I argue for, is that we need to start thinking about these much earlier in our design processes, in our workflows. We need to front-end things like material specification and print settings. And if we can front-end these into our digital workflows, then that means that we can use some digital tools, and we can actually integrate the design of our 3D concrete printed elements into our main architectural design processes. And it also will hopefully mean that we can start being able to calculate the environmental impact of these design processes and understand then how that can then affect the overall architectural project rather than having it all completely separate. So then that sounds great and it should be great, but then the current challenge that I'm meeting and that a lot of us are meeting is that even if we could follow this and we can follow this digital workflow, is how we actually then integrate these new digital fabrication processes, these new materials, the printing cells or robotic cells. How do we then quantify and understand impacts and put those into our sustainability tools? And that's a general challenge within industry at the moment, is we find that, or I'm finding a lot of the standard sustainability tools, we can't add these new material systems in. And so it's also then limiting how we can understand the environmental impacts and understand whether it can be a digital fabrication could be a benefit or a hindrance to our architectural projects. So we need more open databases, and we also need sustainability tools which can calculate the environmental impact of novel materials and also look at broader sustainability metrics. So not just looking at upfront carbon, but also these broader lenses of sustainability, such as circularity, carbon resilience, biodiversity, all these things that we know are really important. And I think, and I hope that if we can actually bring these tools earlier and allow this integration and calculate our environmental impact of digital fabrication, then we would then be able to actually better know how it can support sustainability strategies at our material level, also at a building level, at an urban level, and everything. So that was our very quick run through of some of the research that we've been doing. We made this as like a last slide for you guys to find out some more information if you want to know about any of our projects. But yeah.
We have time for questions. Any questions?
Yeah.
Thank you all for the presentation. I have a question about the urban heat islands. I don't know if you mentioned it, but I'm just curious, like why these centers of the heat changed overnight. Yeah.
Now you can hear me? Yeah. So there's actually a lot of reasons behind it, but mostly because of the material properties. I mean, materials are storing the heat during the day, and when the sun goes down, actually they're emitting the heat to the outside. So that's why actually we are seeing still hotspots during nighttime. So actually this is the most crucial part of this study, because we need to check nighttime air temperature differences because everybody will be in their homes and sleeping. And that's why this is really important. Yeah. Yeah. Any other question?
Is there another one here?
Thank you. Very interesting. I have two questions. One for the zebra fish. So you're saying that what you want to look at is what will the implications be depending on the actually choices made in the design phase. would you be able to retrack that as well and say, okay, once we have these buildings and we can see how this turns out, we can actually count the other way back and see what were the implications, so we could have like a data loop? So that's.
I think that's also an important thing to do, but it's not. I don't think it's yet part of the scope of Zebrafish itself. But it is something that we do through our commissioning work, for example, where we look at buildings that have been built and do they perform the way we intend them to perform, and how do we make sure that we can make the best buildings possible in use. It could be interesting to kind of make that feedback loop back into Zebrafish, but I think the intent with this was also to kind of get a tool that can help us with the existing building stock and quickly identify strategies to, make them more energy efficient, but also achieve a good indoor climate. So it's with a focus on the existing buildings and those parameters, the future climate. So yeah.
We have another one here.
Yeah, it's for you. More of a general question. I don't know if you're working with this a lot or not, but there's many of those tools are coming forth because it's starting to enter regulation. Like you need to meet a certain standard of energy efficiency in order to get a permit. But do you see this, maybe the general tendency, is it going towards meeting those targets, or is it going towards let's be as efficient as possible? Like, is it more of a tool to like, let's prove that we meet the criteria to get the permit and then there, but we have made a tool to kind of be able to show it to get the project? Or do you see this having an impact on let's use this to see what is the most efficient way that we can work? From your, I don't know how much you're working with clients or just on the development of the system, but also what's your kind of perspective?
So before I answer that, I want to quickly say that I'm just an advocate for this tool. I'm quite close to it, but some of the developers are here. We have Morten right there and Sebastian there. Forgot to mention you earlier. Sorry, guys. So if you want to have some more nerdy questions, you can ask them afterwards. But back to your question, I think this tool is more about, it's of course about the requirements we need to comply with, but it's more about the early stage strategies, identifying the big strategies we need to do with this project to achieve more energy efficiency or better indoor climate. So there's not as much focus on achieving a certain target, I think. It's more about, evaluating what's happening if I change the window type. What's the impact on the different outputs I have here? So it's more of an early stage tool to guide you towards a more suitable solution for that project. I don't think there's like an optimum there yet. It's more like an explorative process in the early design stage of the early stage of the renovation project, really. That's where the focus is. Yeah. I don't know if that answered your question.
Yeah, I mean, my concern with those kind of things. My concern with those kind of things, and it might be like I'm new in the industry, and maybe I'm talking out of my what's it called, wage range. But I think in many cases it's quite intuitive. Like, what would be a more sustainable solution? Like a more sustainable material for the walls would be probably more sustainable in the overall. A better, like more reflective glass would have less kind of heating, or like those things are quite intuitive, and we don't need those tools to find the most sustainable tool, the most sustainable choice. But what I'm worried about in those tools is that it would help us actually like round up to say, I know what is the most sustainable thing, but even if I don't use the most sustainable, I'm still meeting the targets because I have this constant feedback. So it's actually, in a way, kind of standardizing that we will meet the targets, but not more, because there is something that's slightly cheaper, and I see that it's still within the range. So it kind of gives me an approval to use it, rather than, because I mean, in most cases we know what would be a more sustainable solution from a choice of 10 different materials or stuff like that. So this is, I mean, maybe not a question, but more just to share a concern about technologies like this that are very kind of number-specific feedback mechanisms.
A comment there, I kind of want to challenge that we always know what the most sustainable solution is. I think what we're trying to do with a more holistic tool like this is to show, When you change the material, that has an impact in itself. It's going to often provide you with some kind of energy saving. But what is the balance there? And that can be a bit difficult. It's quite complex to figure out when is it, good to renovate. Is the investment I do in producing all these materials and putting them into the building enough? Is it the energy efficiency you get out of it? Is that enough to kind of excuse that extra production of materials? And it's quite complicated when you dig down into the details. So we're trying to get that into the hands of clients, for example. That's why Zebrafish is what it is, a dashboard. Yeah, that's easy to use.
We have time for one more question here.
Or maybe a comment. It's Morten.
Yeah, it's not a question, but a follow up, and it's also about the quality of the buildings that we are trying to retrofit, and so it's very important to, of course, it's important to assess the emissions and the embodied emissions and the operational emissions, but it's really, really important, and in my opinion, paramount, that we can increase the quality of the existing building stock to get clients to move towards retrofitting rather than building new, because we need to deliver high-end quality buildings instead of tearing down the existing stock. Yeah.
Thanks, everybody, and let's give Katie, Gylin, and Andreas Rambøll and Henning Larsen a big hand here. Thank you, guys. In 2 minutes, next up is Dalux on stage. Yes. So this year we have been joined by Dalux as a new partner in the partner collective. You're joining us as a silver partner, and we are very happy to have you on board. It's super great to have these visionary companies joining into that partner collective. So thank you for that. And also, Andrew Gamblin, you are representing Dalux and will take us on a journey. Why is construction so complicated? It's a very big question, but I guess you have a simple answer to this.
I hope so, yes.
Take it away, please.
Thank you very much. And hopefully everyone can hear me. So, thank you very much. I want to ask a very simple question. Why is construction so complicated? I think a lot of people here we're all here because construction is quite a complicated industry. The built environment, I encompass this within construction, so please bear that one in mind. But first, a little bit about myself, short introduction. Started my career around 20 years ago now, makes me feel old to say that, in steel supply chain, so big steel fabrication, and in fact we're in an amazing example of a steel building. I've not been in a building like this for a long time, and it makes me very excited. It brings back lots of old memories. Used to do connection designs, steel, secondary steelwork designs, making sure the buildings would stand up. Shortly after I joined that company, I moved to another one, specialized in heavy refurbishments in central London. Logistically challenging, manual labor for a lot of the projects. And there I focused on design, management, as well as contracts management. And it was a lot of fun. After 5 years, I shifted to a main contractor, and that's where I started getting interested in the whole concept of BIM and digital construction. I think within 6 months of me being within the company, I was there at the right time to understand and get involved with the implementation of what was then PAS 1192-2. For those geeky people, that was the precursor to ISO 19650. And if that still doesn't ring any bells, all about BIM management, information management during the life cycle of an asset. 22, I moved to Dalux, and I'm very pleased to be here, and thank you very much for having us here. And we're a construction software platform that looks after the whole life cycle of an asset and the built environment. So that encompasses information management, which is the wonderful area of workflows during the design and construction stages. Tender, which looks after pricing for doing the work on site. Field and infrafield on-site management elements to make sure that the building or the infrastructure asset has been constructed correctly. Then into handover to collect the information to pass on into facilities management for the owner to then operate and maintain. Very simply put, we make complicated things easier to use. So, introduction done. I can get into the nice meat as to why we're here. And I will put it to you that construction isn't complicated, but actually it's very simple. You want to build a new building. You dig a hole. You fill it with some concrete. Next thing you know, you have a foundation. You wait for it to get dry, start building some walls, a little bit of brickwork. Next thing you know, you're up by the roof, put some roof trusses in place, you make it nice and watertight, put some windows in there, liquor paint on the inside, liquor paint on the outside, pipes, wires, lights, everything. Next thing you know, you have a nice little village. Simple, right? It has to be. It has to be simple. You know? Here's an example of a building built, I think it's about 700 years old, still in use today. Another one, I think people know this one, the old Pantheon, 2,000 years old, still standing, still being used. Pretty good example. Take something even more extreme, Incas, Andes, inhospitable environment. Construction has to be simple. Built environment has to be simple. I mean, they constructed this, right? It can't have been that complicated. But I am forgetting one big thing. That was then. Today is a very different ballgame. Back then, health and safety didn't really exist. Today, we need to make sure that the people who go to work on a construction site get home at the end of the day and they can see their wife, kids, husband, partners. And it's a very good thing that we do have these sorts of things. Great set of rules that we need to have. We also have other things. Construction product declarations. Piece of paperwork to say that a piece of steel that's been manufactured is the correct piece of steel, it meets the requirements. You know, we have to have that stuff. Things like BREEAM, frameworks that outline the sustainability of the built environment to make sure the building that is being constructed well. Design calculations. Bring back memories on those ones. They're needed, necessary. Lots of paperwork, lots of calculations, lots of certificates that say that, yes, this has been designed correctly. ISO 19650, suite of actually now 6 documents. The in development is now finished. So we got a nice little information there on health and safety, I believe, part 6 is. ISO 9001 for an individual organization, contract requirements. On-site quality control requirements to make sure that you physically built the building correctly. And Now we're starting to look at it, the EU Green Deal, starting to put in additional levels of paperwork and process and various other things around construction. So it's not construction that's complicated, it's everything else around construction that makes it complicated. The process of doing it is simple. The paperwork is the complicated part. And I know earlier on today with the panel discussion, there was a lot of talk there about data. It's very much one of the big topics. And the reason why is because everyone is affected every single day by the built environment. It has a significant impact on how people live their lives, how they feel, how they are. And so there is a driving need to make sure that it is a positive impact that we have within construction and the built environment on everyone. We need to make sure. And when we do it right, we have some amazing examples. The Opera House in Oslo. Lovely space. If anyone's ever been there. In winter, it can be a little bit difficult getting up to the top, but it's still a very nice space. Wellington, New Zealand. I think it's ranked in the top 10 happiest cities in the world. Great balance between the natural environment and the built environment to make sure people there are happy. Somewhere closer to home, Norrhaven. Recently read that it's a 5-minute city, or designed as a 5-minute city. So everything that a resident could need is within 5 minutes of where they live. Fantastic. Madrid. Used to be a road running right through the middle of the center of Madrid, and they decided a few years ago to rip it up and replace it with a park. Quality of life through the roof. And, as it says here, it's always good when it's slipped forward, if we manage to connect everything together, we can create a sustainable, biodiverse, and engaging environment for those who are in the area. Definitely can do it. On the other side, if we don't necessarily do it, we can end up with cities that may not be the happiest places on earth. And unfortunately, you also end up in other bad scenarios, like, for example, the bridge in Girona, which collapsed due to poor maintenance and a few other things that went on there. And from my side as a British man, Grenfell Tower, and a very similar thing, Valencia. Both of those caused by complete disconnect between design, construction, operations and maintenance. So when something unfortunate occurs, it impacts not just one small area, it impacts the whole building, causes a loss of life. And in that situation where there is a disconnect between these different phases, the question that always runs through my mind, all of this stuff is, if you don't know what you're supposed to be doing, or you can't work with the systems that you're supposed to work with, how can you ever expect to succeed in creating a lovely, positive impact environment? It's very difficult to do so. You need that ability. You need that capability there. Now, it's not all doom and gloom. You know, since I started in the industry around 20 years ago, I'd say in the last 10, 12 years, there's been a significant shift towards collaboration and openness across every single part of a construction project, and in fact, the built environment. People are starting to open up more, talk more. You could say this is down to better visualization through things like BIM. People understand better the technical details of what's going on. I still know some construction managers that don't know how to read a 2D drawing. So how can you expect them to understand what they're building, you know? And that's someone who's involved in the industry on a daily basis. If you have a simple person who just wants to buy a brand new flat, how are they supposed to know what's there? Visualization does help quite a bit. So with this openness and collaboration as a focus, there's some great organizations out there. I know these people have been touched upon earlier. Building Smart International created a lot of open formats that are used across the industry. They provide reliable data exchanges that ensure that the person who is creating the information has the ability to use the system they need and still be able to interact with the other parties on the project. On top of that, if you're looking at more of the process side of things, ISO 19650, these are just 3 organizations that exist around the world that are using the standards or have taken the standards and turned them into something that is usable within the region to ensure standardization of information management through design, construction, and into operations and maintenance. And just with these two things as it stands at the moment, here's some lovely file formats, as everyone knows. I'm guessing most people probably don't know what the file formats are, but basically, IDS, what information do you need? IFC, 3D representation of the data, the building, whatever it may be, along with some elements of data against those objects. BCF, a good way of collaborating between different parties. That's what they're there for. COBie, lovely structured database they use for FM and XML semi-structured / structured data sets. Between all of those and more, you allow people to work in their closed environments, their closed systems, communicate between each other, which then means that you get all the pieces of the puzzle nicely put together. And that's what we're aiming for, right? That's what we need to aim for. Here's some examples of some of these things working here, North Zealand Hospital. A lot of different model files that are all put in place. You can see there point cloud information, scans that we're taking on site, interacting with the 3D models. People understand what the existing condition is, or the snapshot of that condition with the design. People can understand what's going on. And it's not just one discipline, it's multiple. Steelwork, roofing, I believe that one is, or concrete superstructure, and then mechanical, electrical. All these things all come together to allow people to collaborate and talk design, construction. Infrastructure, another example, very similar. Rather large project actually. Just to give a sense of scale, here's some zoom-ins on little sections. You can see there topographic DWGs mixed with the design intent as to what's there, and even some point cloud information. You can understand the impact between the design and the realistic, or the reality. This is what it enables us to do. This collaboration, this openness with these standards that have been put there. They're working very well, and the key part there is the connection. The connection between the different data sources. Connecting the data together is a key aspect of what we're talking about, or what we need to do with construction to make it less complicated. But we still have some big challenges, some significant challenges within the whole of the built environment. And I'll talk about two. The first one, we want to be able to create something that is actually sustainable, trusted data, trusted information. We have to go to the source. The source is the manufacturer. That's a tough one. There's multiple different systems that they could be utilizing, different data sources they could be going to. A single source of truth, that's what we all want, right? Luckily, digital product passports, as part of the construction products regulations within the EU that come into regulation, they should enable people to have a digital, traceable way to understand the main bits of information, sustainability or otherwise, for each product that goes into a building. And luckily as well, manufacturers are realizing this. There's now a push for some kind of information hub, something there that points the people who need the data where to go, where they can pick the data from, which of the manufacturers it is that has it. Very, very good piece. So a foundational element that we need to get sorted within construction. The second one is on the other side. If you want engagement, it needs to be clear, it needs to be simple, it needs to be visual, and it needs to bring everything together. LCA data, embodied carbon, environmental data. Combining that with databases of information from product manufacturers. Combine that with the 3D models. Combine that with program data or some kind of timeline data in terms of maintenance requirements, or over a period of time, this is what the CO2 levels within the room are, etc., etc. That all needs to be connected together in a lovely, neat way that it will never look like that, but, you know, and that's a small subset of what it could be. But if you're able to visualize that clearly, succinctly, easily for the end user, they're able to understand the impact for them and what they need to do to make sure that there's a way forwards. It's a key aspect. So it doesn't have to be complicated. Construction doesn't have to be complicated. And this event here, connecting different people, different skill sets, hopefully giving themselves another way of looking at things can help to make the industry as a whole, make it nice and simple. But thank you very much. That's it. Yeah, by all means.
So thank you for a very interesting presentation. It was nice to see that you took us from the complicated to simple to not so simple to actually simple, right? So
yes.
Nice, and thank you for bringing this example. Does any in the audience have a good question for Andrew and Dalux in regards of what we learned just now?
Silence is great. It means I must have hit all
There's
the
a
notes.
question from Sarah.
Okay.
Yeah. So, Sarah?
So I'm not going to pretend like I'm a professional in the building industry, because I'm not. But I do. You're mentioning about the trustworthy data from the manufacturers being like the basis for this whole loop.
Yeah.
But how do you actually ensure that the data you receive from these manufacturers are accurate? Because they have the incentive to make it seem better than maybe it is. So how would you know?
It's a tough one, and I think it's a discussion that, as a global industry, because a lot of these manufacturers act on a global scale. Take a Tata Steel, a Saint-Gobain, Cemex. They operate in multiple different markets. There needs to be some method of checking that the data is correct, I think, and then trusting it from that point. So it may add another layer of complexity in terms of regulation on top, but if that's what's necessary, then I think that's the way that we need to do it. Digital product passports, I think, is going to be the first step towards that. The industry has to start somewhere, is one of the things. And I think with the DPP scenario, hopefully it'll kickstart it in the right way.
Thank you, Andrew. And do we have any other questions from the audience here? Doesn't seem like it. I have a reflection. So this is the first year having Dalux on board as an AC Hackathon partner. What do you think? And it's more on a personal note. What would you say is the important thing about joining as a partner in a hackathon? What are the mechanisms that we thrive to engage here and to make blossom in this setting?
So I think it's the communication collaboration aspect, bringing together multiple different people from different parts of the world, different industries, different companies, all with a singular goal, I think is a key thing. And these kinds of events are brilliant for having that kind of different perspective on the same issue, is what I would say. And we're just glad to be here.
Awesome. Thank you, Andrew, and thank you, Dalux.
No problem.
Okay, so next up is a short break again before we continue with Christopher Ditchens from Ara 3D before the podcast. Thank you, guys. So welcome back to the Tech Talk schedule. With us now is Christopher Dickens from our 3D. Christopher, you come all the way from Canada. And just before you start, can I ask you, why is it so important to travel all over the world, crossing oceans to join a hackathon? Why did you decide to go this time?
So this is my great. So thank you very much for having me. It's a real pleasure to be here. It's my first time in Copenhagen. Thank you. We're just going to give it a second for my slides to show.
Just take it a second. Sorry, we have a slight issue with the sound. Just give us a few seconds here. I'm sorry, Christopher. It wasn't to interrupt you. You are here in Denmark to join the AEC Hackathon because as a programmer with a lot of experience, it is important because of?
It's important for me to learn what is happening in the industry, how people are using their software, what problems they're struggling with, and how technology can be developed to solve their problems.
I think it's extremely awesome having you here in Copenhagen, joining all the way from Canada. Thank you, Christopher. And without further ado, I'll let you do your presentation from here. Thank you.
Is high-performance C#. High-performance computing has a very specific term for computer scientists, but in general, I just mean any code that's aimed to be efficient and potentially run at real-time. Really, code is about addressing performance issues, obstacles that are preventing our code from running and utilizing the full resources of our computer. So really what it boils down to is actually discovering what's wrong with our code. Why isn't it performing as well as we expect? I've been coding for about 40 years, and the computers I'm using today, my laptop, are far more powerful than I ever imagined I would have. When we think about high-performance computing, sometimes we're thinking about squeezing every ounce of power we can from the computer, but really what it boils down to is actually avoiding performance issues. And they primarily stem from inefficient algorithms, poor choices of data structures, and underestimating data retrieval. In general, these are the fundamental problems we have in our code and that prevent it from executing at the fastest possible speed. So, in other words, the most effective thing you can do to write high-performance code is to understand your software and understand how your computer works. This is quite complex. Modern software is incredibly complex. There's so many layers to it. There's so many abstractions. The same thing is true for our computers. Modern computers are very complicated beasts. So we're going to focus primarily on abstractions, thinking on a very high level, using a simplistic model of understanding of how our machine works that is still accurate and can allow us to improve the performance. So today we're going to focus on getting excellent performance in C#. As I mentioned, my name is Christopher Dickens. I've been programming for about 40 years, focused almost exclusively on desktop computing. I have done web-based computing, but really my specialty has been on desktop computers ever since the Atari 400 came out. I've worked at Autodesk, Microsoft. My hobby is coding, and so I'm really lucky to be able to do it as a profession. My product, briefly, that I've been working on for the last couple of years is called Era 3D Studio. It's a Windows desktop tool. It's not out in beta yet. We're hoping in about 2 weeks we'll be having a public beta, free beta, start getting feedback from people. It's designed to meet the needs of AEC professionals, and what's going to set it apart is the ability to load the largest AEC models we can imagine, integrated with large amounts of geospatial data. The other thing that I'm focusing on is allowing it to be extended by programmers and computational designers. I've written the entire program in C#, and that's kind of a surprising decision for many people that I know and many software developers. So the question is, why did I do that? Well, it's a lot easier as a developer to have only a single code base to worry about. So I don't have multiple math libraries, multiple technologies that I need to switch between. Scripting is a fundamental component to my language, to my program. Like many 3D programs, the ability to write scripts and plugins is very important. So having C# as both the scripting language and the language of the infrastructure allows script execution to happen much faster because the two are integrated together. So unlike the Unity game engine, for example, which is written in C++ and has C# added as an afterthought, it's fully integrated. C# is a safe language, which means I don't have to chase as often resource allocation issues or memory buffer overruns. It's still possible, but it's less common. The other aspect of it that I think for me is really, really important is the fact that there's great high-level libraries, especially the UI library, WPF. So this facilitates the development of the user interface that I want, and the tools are just awesome. If you're really astute, you'll probably say to me, well, is it really all in C#? Well, technically, no. It uses a library for graphics called OpenGL, and that's actually written in C. OpenGL additionally uses a language it itself uses called GLSL, which is used for the executing code on the GPU. This is for executing the coloring of the individual pixels, which is called a fragment shader, and as well as computing the colors and the normals at the vertexes for doing lighting computations called a vertex shader. So how important is language for performance? Many people think that, oh, if I want to write high performance code, I have to use a language like C or C++ or the new kid on the block, Rust. The truth is you can write efficient or inefficient code in any language. And performance bottlenecks, if they exist, they can always be offloaded to another language. You can offload computation to the GPU by rewriting it in a shader language like GLSL or HLSL or any myriad number of languages that exist for GPU computation, even OpenCL. All languages have performance limitations. They're all high level. And when you really want the absolute fastest code, when you're going at a level even further than I go, like if you're doing scientific simulation, of weather or nuclear war or whatnot, you're going to have to go to code generation. So in mathematical code, often you're going to say, well, the fastest possible code I want, I have to generate specialized algorithms for different purposes. So in an extremely high performance situation, you are going to be generating code. And high performance math libraries using game engines, they resort to this. The .NET runtime code, it uses, like for the Eric's library, they use code generation. And I've used that as well in my previous libraries. The trick to making any language fast is to help the language generate efficient assembly code. And to do that, you have to understand what your code is doing and how the compiler is translating it. As I said, though, modern software and CPUs are really too complex to understand fully. If you try to go deep, deep, deep into one area of the execution of CPUs, you're going to be missing something. I'm going to get a little pedantic for a second. The question you really want to answer or ask yourself if you want to write high-performance code is, how quickly can you create and modify code that meets your performance requirements? It's all about requirements. There is no such thing as the fastest code. You can always speed up your code. So you have to understand your performance requirements. So this is where it starts, and it's often overlooked. So the questions you need to ask are, how fast is sufficiently fast for your purposes? What is more important, responsiveness, latency, or throughput? Sometimes it's sufficient for the code to be responsive, and to take a longer time to execute as long as it's responsive. That's something that's easily overlooked. How accurate or up-to-date does the data need to be? If you can commit the data at a later point, then you can use that to do background computations. If it doesn't need to be as accurate, you can scale down accuracy. So you have to figure out what work you really need to do now versus later. This is all about understanding your performance requirements. Ultimately, when we're writing code, you're balancing two things, the abstractions and your performance. So the abstraction is the tools that you're using, the high-level tools like the classes, the interfaces, the higher-order functions that are used to reduce the amount of code that you have to write and to make it easier for you to maintain your code and to make changes. There's no such thing as a free lunch, though. Every abstraction does have a cost. You're either going to have a direct performance penalty that is observable, or what's going to happen is because of the thing that you're doing, the virtual function lookup or whatnot, it's going to actually affect your compiler optimization. So the compiler is doing a lot of the work for you of generating the fast code. If you focus too early on optimization, though, your code becomes harder to understand and modify, and you start to hide your inefficient algorithms, your data structures, and your bugs. And this is what I see all the time in code that was supposed to be fast. Code that's pre-optimized, and it's actually doing something incredibly stupid under the hood. It's just nobody's really paying attention or doesn't understand the code. So if you obfuscate your code and trying to make it fast, you're doing yourself and others a disservice. And it becomes very easy to focus on the wrong thing. So the high-level advice here is write concise, clear, and correct code first. Do use your abstractions. Only create specializations when performance is required. Don't throw away your abstractions. Create a specialization. If you have a specialized use case that needs to be extra fast, add a new function or a new class to do it. Measure, measure, measure. End of the semantic section. Let's talk a little bit about how C# works. And I bet a few people who left were kind of hoping I was going to talk about how properties are slower than field access and why you should use ref structs versus whatnot. None of that matters. All of that turns out to be garbage. You do have to understand, I said at a high level, how C# works. I aced my assembly class in university without writing a single line of assembly code, because what I tried to do is understand how the assembly worked. And then I was able to fake it, so to speak. It's a high-level understanding. Even if you think you understand what's going on, you're still working with a high-level understanding of what's going on. You're always abstracting details. But the most important thing is to know that C# compiles to bytecode, but that bytecode is like a simplified assembly code. It is a good thing to learn, actually, bytecode. It's actually more important to learn the bytecode than it is to learn the low-level assembly, because assembly can be quite complex. The algorithmic complexity is one of the most important things. And in fact, this is the thing that will have the biggest impact on the performance of most code I've seen. So what is algorithmic complexity? It's a mechanism we use for expressing how long a computation will take relative to the size of an input set. We use a measurement called big O complexity in computer science. We have big O of 1 means that no matter how big your input set is, the time it takes to do that processing will be the same amount, constant. This is an abstraction, right? O log of n. So the way log of n works is that, let's say it's the number of bits it takes to express a number. So, 1,000, log of 1,000 is 10. Log of, 2,000 is 11, and so on. So as you double your numbers, log of n just increases a little bit. And you double, and it increases by 1. O of n is linear. So this is what you're kind of hoping for, is that if I run through my list of items, I'm going to hit each one only once. Sometimes what we're doing is we're running through the list, and every time we want to do something, let's say you're searching through the list, you search through it each time for each item. And these tend to be the more inefficient algorithms. I don't have time to teach you big of O. This is like a big chunk of a class in computer science.
Exponential.
Oh, exponential, like traveling salesman.
All the time.
Yeah.
Exponentially harder.
Yeah. Usually when we say exponentially, we actually mean logarithmic times linear, but that's all good. The point is that there are these classifications. And if you go from one to the other, the performance change is off the charts. You can't even compare them. I want to talk to you about something else for a second, about data storage. I want to do this little thought experiment. I have 1.2 terabytes of digital elevation models, like terrain models, stored on a server somewhere in North America on an AWS server. What's the fastest way to get it to Copenhagen? Any guesses? What? Undersea cables. No. You know what's faster than undersea cable? Airplane. SneakerNet. Yeah, SneakerNet. This man's speaking my language. It's literally big in my computer with me. Flying with my hard drive. There's a hierarchy of cost related to data access and data retrieval. If your data is in your register, like less than a nanosecond is like a clock cycle to get it. If it's already in a register and you're like, oh, I want to read that register. It's like instant. Registers can be anywhere from 8 to 256 bits, some cases 512. I'm generalizing here massively. Like this is a huge amount of hand waving, but that's all you need. You just need to know that registers, they don't go much bigger than that, and it's a clock cycle. If you're accessing memory that's in your L1 cache, which generally per core is between 60 and 128 kilobytes, access is on the order of 1 to 4 nanoseconds. Keeps going up. L2, L3, then your good old RAM. My computer is 64 gigabytes of RAM. But if you're on a hard drive, it's 1 to 4 terabytes. But this is not relative. Like these are like 10 times slower. So 10 times slower than a CPU register, or the different caches, than RAM, than local storage. It's the most basic thing. Cloud is slower than your hard drive, slower than your RAM, slower than caches, slower than registers. I had a whole class dedicated to this, but you can summarize it in one slide, but people don't understand that, and that is the biggest mistake I see people make next to algorithmic complexity. So if you just want to squeeze out more performance, just put your data where it should be. C# has pointers. Just about every language does. Even JavaScript's got pointers if you want. They're there. They're called something else, typed arrays, whatever. In C#, if you want low-level memory access, you have a couple of techniques. You need to make sure that you're using what's called unsafe, which is kind of funny. It's not. It scared me for so long, but it's actually not that scary. It's not bad. You do much worse things with your file system, trust me. You just need to say, well, this memory that I allocated using my garbage collector, don't move it. So fix it. Because the garbage collector will take this liberties and will move memory around to optimize it. But here's the thing. You'd think that this would be a great way to speed up your code. It's like, oh, I'll use pointers and I'll directly manage my memory. Surprisingly, no. Actually, what happens is it goes, oh, you want to do it? Okay, you do it. And the compiler kind of steps away and says, well, I'm not going to touch that anymore because I don't know what you're doing. C# compiles code to assembly at the last minute, and it does quite a very efficient job. This is another technique that not many people are aware of. For ages, we've actually had registers. Well, people know that you have a floating point value, 32 bits. It fits in a 32-bit register. But on most computers nowadays, we have 256-byte wide registers. What that means is you can actually put 8 floating point numbers in a single register and do operations on them at the same time. You may try to get clever and start using it and go, oh, I'm going to get 8x speed ups on my code. Well, the libraries you're using are probably already using these SIMD operations. So in some cases, you actually get 0 speed up. If you're doing simple numerical access in order, like a for loop, and you're saying, oh, I'm going to go over my memory one by one, the compiler will actually optimize it for you and use the registers. But it's a useful technique to know when you need to squeeze out extra performance, and it's part of understanding how the computer works. The other problem with it is that your code becomes more complex. It's got to be aligned properly, and it's not 100% portable, so not all processors have that access. One of the reasons I like C# is it's, generally speaking, very portable. It runs on all sorts of devices, machines, and I don't have to special case my code. This is where a lot of people start when they start thinking about performance optimization. They start thinking about the instruction timing hierarchy, and that means that different types of instructions you do have relative costs that are bigger. And I'm not even going to start giving you values for this. It doesn't matter. Like I know I've researched it, and you can get like, well, that's 1 clock cycle, and that's about 4, and that's maybe 6. It doesn't really matter. Integer arithmetic is generally slower than floating point arithmetic, which is generally slower than static methods. Boxing on boxing is when you cast it to objects, so your data structures become heap allocated, garbage collected objects, or back. Exceptions generally are surprisingly slow, but don't be scared to use them. Reflection is when you're asking an object, hey, what type are you? What methods do you have? I don't know anything about you, but look for a method and then I'll call it. That's a very powerful tool. It's used in serialization where you're converting to XML, JSON, whatnot, but it's very, very expensive. And then one of the worst is actually context switching, which is kind of surprising because we want to do multi-threading of our code. There's actually a huge amount of cost when you have to switch between threads. So when the system has to move data from one thread to another and change its execution context, there's a lot of cost. There's a small hierarchy related to method calls. If your method, your function, can be inlined, and you are providing it with the tools so that it can be inlined, which means it's small and there's no complex branching, it's likely to be inlined. If it's static, it's a little bit faster than if it's virtual or if it's an interface method, which is also faster than if it's a lambda function or a delegate. Coming back to the subject of multi-threading, I love this quote. Read it for a second. You have a lot more than 2 problems. I've seen actually a lot of code that got multi-threaded. Not only did it spontaneously erupt in tons of new bugs, Heisenberg bugs that, you know, as soon as you looked at it, the code was like, whoa, it's not doing the same thing. It actually started executing slower. And the only thing he had to do was like undo all the multi-threading he did to speed it up. And oh my God, on all of the forums, when I was at Autodesk, everyone said, you should just multi-thread your code, make it faster. Virtual functions are kind of funny. Like the penalty, so people will say, hey, avoid function pointers and your code will be faster. And other people will say, well, no, function pointers, virtual functions are actually quick. Sure, they're quick and there's very low impact, but what they do is they inhibit compiler optimization. Your compiler doesn't know what's beyond the virtual function call because it moves to code based on runtime conditions. So your compiler can't say, oh, the next thing that's going to happen is over there. So it has a hard time predicting the next call. So because of that, it can't optimize code as a whole. So the actual penalty is really related to its impact on compilers' ability to optimize. Again, remember what I said earlier, use abstractions, use virtual functions, but when you need to speed things up, that can be a culprit. Measure, 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 measure. Always measure your code. Measure it in context, though. Don't just look at one function and say, oh, are you a fast function or not? It doesn't matter if that function's fast or not. What you care about is whether your entire, your program is fast in the parts where it matters. So once you know your requirements and you have a place that you want to make faster, you'll measure it. Make sure you use real-world data. I've worked on failed projects at Autodesk where the team was only testing on small toy data. And their customers were using their projects. And guess what? Their customers did not want to use the product because it was never tested on real data. Feel the pain. We call this wear the hair shirt. Like, you got to know what the pain is that your customers are having. And so put in the biggest things you can. Test the failure. Break your damn software. Because you might actually find surprising bugs that only occur when you really put in the big data. So look at the overall performance. Do not start with micro benchmarks or profiling. Remember about the code structure. So this is actually an unpopular opinion. I would have failed one of the interviews with my boss back at Autodesk because he's like, oh, how do you speed up your code? And he's like, unless a person says you must use a profile, because what do I start with? I start with understanding my code. If you don't understand your code, if you don't understand what it's doing, it's pointless. The profiler is not going to help you. It's going to say, well, that function's slow. Well, if you're calling it n squared times, well, that's stupid. I mean, it's not that it's stupid. It's just that, well, it's stupid. So, the other thing about calculations, you should have an estimation of how long it's going to have. I read a post where a fellow called this the speed of light computation. How fast could it possibly go? So, like figure out kind of like a fake thing where you take out, well, let's say we'll take out the file I/O, or we'll take out some aspect of it. You simplify the program and you make a fake test case, and you're like, no matter what, I cannot beat this speed, and you can time it and measure it. And at least that gives you a sense of where you're trying to go. You're not really trying to get there, but at least it tells you you're not optimizing for an impossible case. So what are your reasonable targets? And that's really good to know, because if you're like at 1/1000, it takes you like 1,000 times longer than a reasonable target, well, there's a problem there, and you should fix it. And you have to understand that. That's, again, a mistake I see people making. They're like, that seems plenty fast for my code. Seems is not the same as should be. If you have done any C# programming, you've probably heard about LINQ. It's a great syntax for doing very complex operations with a very simple syntax on your collections. And all through the Unity forums, everyone's like, do not use LINQ. It is slow. It's a performance penalty. Sure, yeah. It has a performance penalty. It's a bit hard to optimize, but it is super convenient. But I want you to consider this code. This is an example of LINQ. This is a generator. Clearly, I'm generating random values up to some input number, n. So I've got my random number generator, and just for debugging, I'm going to write out to the outline, I'm generating the ith number, and I do what's called a yield return. So the way yield return is that this whole function kind of acts like a class with state, and it is called over and over again to generate my values. It's a generator. C# calls them enumerators, which is a little confusing for my brain. It's a type of coroutine. So here's an example of me testing it. For each var x in 100 randomly generated numbers, I'm going to select, this is a transformation function, this is a lambda, I'm going to square root it. And then of all of this, these are chained together, I'm going to take 10 of them and I'm going to write them. So my question to you is, how often is this called and how often is this called? Yeah. What's select do? Select will take my initial collection, create me a new collection by applying this computation on each value. It's map. This is a map function. Again, C# decided to get a little special. It's also called a comprehension if you're a Python programmer. Does anybody have any guesses as to how often and when we see each of these functions called?
No, wait.
Which one?
So the generator would be called. Oh no, it's going to completely generate all of them.
It's going to generate all 100, and then it's going to
transform all of them, and then you're going to take 10.
Yeah. Actually, what it does, it's lazy evaluated. It's only 10 times. So this is the surprising thing about Lake. It's actually immensely powerful as an optimization technique because it only is call and demand. So if you see this little thing, take forces the evaluation only 10 times. So when you actually run this, you're going to see it run, 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 and only does it 10 times. So your algorithmic complexity dropped. So phooey to all those people that said enumerable.
Where's that happening? Is that in the... But is that a C# thing, or is that something in the library somewhere? The link library?
This happens as a transformation. For each says, get me an iterator. Initialize it. Initialize my iterator. And now, for each, what it does is, it's kind of like a for loop in disguise, which says, get the first value. Okay, is there a new value? If so, get it. This is transformed into a class that wraps the iterator. So this is kind of like, these are two little syntactic transformations. But lazy evaluation could decrease algorithmic complexity. Final words, it's all about the algorithm, not the language. Don't believe anyone who tells you you can't write fast code in language X. So I will open it up for how many minutes of questions?
Just half a minute. We are a little bit over time.
Oh, thank you.
Do you have time for a quick question?
Yeah, fire away. Perfect.
We don't have a lot, but
You have my LinkedIn information. Text me your questions.
also, for the people out there on the stream looking at this very inspirational tech talk, reach out to Christopher if you have anything to ask him about. I'm sure that you are more than willing to interact with the
I enjoy this
audience.
Immensely so, yes, thank you.
We did as well, and thanks a lot for joining us all the way from Canada. I'm still, it's awesome. Thank you. Thank you.
Thank you very much.
Thanks, Christoph. Okay, so next up is the podcast with Zero. We will just quickly rearrange the area here, but stay tuned. We have a couple of very experienced as well guests for this podcast. So stay tuned, and in a couple of minutes we'll start that in the room here in Arena. Thank you. Presentation brought me years back. Yeah, you can almost feel the atmosphere here in Blocks Up. We are warming up for the next session. We have a podcast coming up with Matthew Jackson, Torben Klitgaard, and Ole Berat, and they're going to speak about carbon emissions. It's all good. We are empathizing on the good atmosphere here at Blocks Up. So Matthew Jackson, without further ado, I'll actually just hand over the word to you for this podcast session for the next 45 minutes. So thank you for joining us, guys.
Thank you, and welcome everybody. Very big thank you to Blocks Up and AEC Hackathon for hosting us. I'm joined at the table by Torben, CEO of Blocks Up, and Ulla, who has so many job titles I can never remember exactly what you're doing. So please, can you start off by introducing yourself to the worldwide?
Yes, I also struggle with remembering what I'm doing and trying to do the least possible, but I never succeed with that. No, I work for Molio and use most of my time working with Contact Lab, which is this place where we try to push the Danish construction industry towards becoming a little bit more sustainable, a little bit more productive by using technology.
Very nice. Torben,
yeah.
You can introduce yourself properly to everybody.
I will. Yeah, I have the privilege of actually having the same title for the past 7 years, so I haven't switched on that. I'm the CEO in Blocks Up, as you rightly said. Now going down 7 years. We opened up in 2018, as you maybe recall. Yeah,
I do recall.
Time's fast. Sitting physically here downtown in Copenhagen in a building where the mission is to reach out to the built environment, broadly speaking, connecting, creating networks across stakeholders in order for all the different companies, NGOs, scientists, startups, corporates, etc., to create a comprehensive, sustainable impact in the cities in the years ahead. And that we do that by having a co-working space in the downtown area in Copenhagen, and we do that by reaching out to quite a wide variety of international networks, boosting the Danish companies internationally and welcoming international companies to the Nordics.
Very nice, very nice. Well, we're sitting right now in the fantastic Blocks Hub, and we have beer as well. So I guess we should start this podcast off by saying skål.
Thank you very much.
Cheers.
First of all, thank you very much. Thank you very much, and skål to everybody at home. So,
celebrating the first day of spring.
It is indeed the 1st of March, and it's a beautiful day here in Copenhagen. And we're here to talk about something which I've learned over the past few years, and is kind of my starting statement, is that obviously globally in construction, we're all kind of racing and trying to do different things to become more sustainable and decarbonize. And of course, the work we're doing at Zero is to spread that education. But one thing which I think is quite clear, I think Denmark as a government with policy is probably the furthest ahead in its journey on building an industry which is focusing on decarbonization, or at least measuring the impact that the built environment has on the world. So one of you, I'm going to probably lean towards you first, or like explain to the world, because I think a lot of people don't understand what Denmark is doing and what Denmark has done to kind of get to this stage. So kind of give us an overview, explain it like I'm 5, overview of how Denmark is progressing in this space.
I'm a little bit nervous because Torben is here and he knows all the historical facts, and you just turned on ChatGPT.
Yeah, I have ChatGPT ready to fact check these guys.
I thought I was the fact checker. Okay. Oh my God.
So I'm a little bit nervous in telling the story. I think what's interesting about Denmark is that there's actually, I mean, it's very much part of our culture.
Yeah.
I mean, that Denmark has been working with sustainability for the last 30 years or so. I remember my parents taking me around in the 90s to visit the different experimental buildings that built with seaweed and out of bottles and out of all crazy things. So I think basically Denmark has this foundation over the last many years to build and to live in that way, and it has been very much part of the identity. I think what happened recently is both that the industry actually wants to do something about it. So there's a lot of maturity in the industry, and many companies have been asking for regulation, because for some reason the only way to change something in the construction industry is if somebody asks for it, either the government or the clients, and then it's always easy for the government to ask for it. So the Danish industry is kind of masochistic on that point. Please give us more regulation. And the what's it called? The Danish government took them up on that. I would say in a quite interesting way, because we started with a little test project called the voluntary sustainability classes, which is now 4 or 5 years ago that we started doing. I think it was supposed to be 30 projects, but ended up being more than 50 projects, where different elements of these of the new legislation were tested to see, is this actually doable? Is what we are.
When was this? When did this kind of kick off and get started?
I think it's probably 5 years ago, similar when Contact Lab 2020, 2019, somewhere around that. I'm a bit afraid of facts.
No. We will fact check you later. It's
somewhere around that, we started with that, and clients committed to this voluntary sustainability class, and companies committed. Realdania put a little bit of money into it. As I said, it was supposed to be 30 projects, maybe 40. It became far more projects. So the different elements of this new legislation were tested, and then 2023, Denmark implemented the first round of requirements, 12 kilogram CO2 per square meters, and us that are a little bit more, that a little bit more progressive, a little bit disappointed for that, because it actually was standard practice, or standard practice was below that. But already this year, it's going to be more ambitious from July, and over the next 2 years, every second year, we'll tighten the screw. I don't know if you say that.
No, that is the good way to say. But it's interesting, right? Because obviously this legislation came into effect in 2023. You said
I think you're actually right. It's 2023.
But it's quite it's been a long road, right? I mean, from my understanding, at least what I quote is that in the big Paris COP in 2015, kind of Denmark announced it wanted to have the world's first carbon neutral capital city, right? That was the kind of the big kickoff, or where does it kind of really come from?
Well, I'm afraid that's only partially true.
Am I being fact checked?
You are being fact checked
Okay.
now, right this minute. Yeah, no. Well, being the oldest in this panel, I have to think way back here. You're right, of course. The government has a crucial role to play. Bear with me, but I think going back to 2007, actually, way back, almost 20 years now, the Danish government actually put forward legislation that public building owners should enforce digitalization within the construction industry in a whole new way. The industry wasn't ready. The level of tech wasn't ready, if you ask me, at that point in time. But from a government point of view, from a political point of view, it was sort of a wave being pushed forward. And that all more or less, there might be people in the audience saying it actually happened before 2007, but let's just start up this in 2007. And that actually kicked off a whole wave of partners coming together, the initial requirements from the public tenders, the industry getting together, the tech rising slowly but gradually. And I think, the BIM movement there started, there was sort of considerable moves ahead within the BIM community in Denmark at that point in time. But you're right, coming to the Paris Accords, well, if you would, now we're sitting in downtown Copenhagen, and Copenhagen was actually the first small capital in the world to put out its head saying, hey, we want to be the first carbon neutral capital in the world. That was, to be correct, back in 2012.
Okay.
With an overall sort of target of hitting the CO2 neutral level in 2025, which is this year.
And are they on target? Do you think to hit
no,
it?
They're not on target. And we realized that a couple of years ago. So we are sort of roughly 75% towards target.
Which is still
quite good.
Incredibly impressive. Like, let's not
You're right.
that's not amazing.
Of course, we're talking about energy consumption and energy production and mobility as sort of the three major must-win battles in order to create that and achieve that climate neutrality. The city of Copenhagen has put forward a new climate plan, reaching 2035, as I recall it, coming up as a complete CO2 neutral city. But it certainly spawned a lot of innovative projects and innovative ideas in pushing that agenda.
And I guess this is probably where the key part of the counting, right? So obviously, we know that the built environment is probably responsible for around 40% of CO2 emissions-ish, right? Give or take, depending on where you are in the world, of course. So obviously, having a very good and detailed understanding of new construction and renovations' impact on this equation, let's call it, right? This balancing out of the scales. So we said that you're measuring, was it 12 kilograms per square meter? Is the minimal? Well, sorry,
It's
maximum.
Maximum.
Sorry,
that's the one right now, and it will go down to. It's a bit differentiated, but I think it's 8.5 in average. People keep saying. So some buildings are a little bit less, and some buildings are a little bit more from July.
So what is the process of that then? So from what I understand, that a building has to get planning permission, to get kind of your permit to build, you have to deliver some level of evidence that can be achieved. How's that kind of working?
Well, I think mentally it works in the way that the new mindset here, the new way of thinking in construction is that you have not only a construction budget, you also have a CO2 budget. And those two have to balance.
Yep.
You might come up with great plans, but if the CO2 budget is too high, it creates an imbalance. And the people surrounding the project, the building owners, et cetera, has to take that into account. But it's gradually decreasing, as you mentioned, round eights. Don't correct us for the figures, but and even going further down. But I think there's a constant push on that figure going down, down. And if we have to take into account the Paris Accord of the global warming not exceeding 1.5 degree, it has to come as low as 0.4 or something like that, which is dramatically lower than we are building right now. It's roughly, according to the average right now, if we do the math quickly, it's sort of roughly 95% reduction compared to the level where we are now. So we have to talk about fundamentally transforming the built environment if we have to stick to the Paris Accord of the 1.5 degree. And that is a challenge ahead of us.
So let's take that challenge and let's go down that rabbit hole. The challenge seemingly is it's not just it's technological, it's cultural, and it's supply chain. It's a material issue as well.
Sure.
I mean, concrete. Again, fact checking here, guys. Like concrete, I think is global CO2 like 2-3%. I think cement, like just cement production. Globally is huge, and we use all of it. Let's say construction, apart from the block in the bottom of your washing machine, so your washing machine doesn't dance around your bathroom when it's spinning. I mean, that's the only other use of concrete that I can think of.
Yeah, lots of washing machines globally, if you count that up.
True, but still, compared to the concrete we use in foundations, it's probably
it might
minimal,
exceed
right?
It might exceed.
So I mean, so what really do you think is the driving approach that's making the Danish industry really strive to do that? What's the big approach? Oh no! Oh no!
No, well, the easy answer, it's a systemic approach, and what does that mean? I think it really a key figure in this equation is the role of the states. So national regulation, national push. Going back to my earlier remark on this 2007 legislation on digitizing the construction industry from within, I think that goes for this movement as well. The market cannot, I'm a true believer of market economics, but it cannot stand on its own. That there has to be sort of a public-private collaboration on this. So public-private collaboration is truly a sort of it's not a Nordic invention, I know, but it's truly something that we have worked on for many, many years. And going back, I'm a trained economist by training, even though it goes back some years now. And when you start up at the business school, you learn about the monopoly, but you also learn about monopsony. And monopsony is the fact that you have one big buyer, so to speak, which is the state, which is the region, which is the municipalities. So in Denmark, we have throughout time, more or less, had a tremendous opportunity of actually pushing forward new waves of innovation, new waves of doing different by using the power of the monopsonist.
Yep.
And you're talking about that in the States right now when you talk about tariffs, et cetera, et cetera. But that is truly a value living in a country where we have almost 50% of all financing within the built environment comes from either the state, the regions, or the municipalities.
Yeah. Which makes
so it's
perfect
a tremendous buying power you hold in your hand.
And it makes perfect sense because we're not just talking about buildings here. Of course, we're talking about infrastructure. I mean, virtually all infrastructure expenditure comes from states.
You're right.
You know, trains. I mean, some power is privately funded, of course.
And it goes across, of course, other industries rather than just the construction industry. But sort of the by far biggest builder as such is
the state,
the public realm.
And I think it's very much. I mean, it's very much rooted in the people. It's very much rooted in the public. So there's an what's it called? Honestly, most Danes care about the environment, care about the planet, and want to do something about that, and also want the government, want the state to do something about that. And that might sound a little bit funny, but it is. That's not everywhere. That's
True.
not like that everywhere in the world. I think. Many people are quite happy about AI also because then we don't have to discuss sustainability anymore. We can talk about AI instead. But that's different in Denmark. It's, as I said, it's part of the culture. It's something that we all grew up with the last 40, 50 years is we want to do something about it. So everybody basically supports it.
And that is a very positive thing to hear. I mean, just anecdotally for a moment, I mean, within the Zero community right now, there's been a bit of what I would call disappointment, I think would be the right way to say it, is that politically, at least on the macroeconomic level and kind of macro political level, sustainability has kind of dropped off the menu, and for good reason, of course. We're living in a world of challenging geopolitical situations. We have energy crises, immigration crises, etc., depending where you are in the world. And just last weekend, from the German elections, I think sustainability dropped from people's voting power from like number 3 all the way down to like bottom, like down to number 8 or number 9, which is disappointing. But of course, it's interesting to hear from you there that Denmark, it's still a big thing for you guys as a population. It's still very much top and front of mind.
Yeah, and I mean, don't want to discuss politics that much, but I think also in Denmark, also in Germany, one of the challenges is that the what's it called, the public actually was not necessarily behind all the decisions the former government made. So the public actually got a little bit sick and tired of sustainability and how the former government handled sustainability. And here in Denmark, I think most people actually agree with the decisions. I mean, we're a little bit sick and tired of having to what's it called. Divide our waste into 15 different bins, but also that is being accepted.
Yeah, no, very good. So let's swing back to the topic, right? So we're measuring carbon. We've got to deliver projects at 12 kilograms. Yeah. How on earth is Denmark even measuring that from a deliverable perspective, right? So I finished my project. The government is my client. How is the government now checking that I've built my project to 12 kilograms? This is the interesting question.
Yeah.
Because this is the question that I have always front of mind is, you make a law, how is that law enforced? Like, or how is it going to be enforced? Maybe it's not enforced yet. Maybe we're not at that stage.
Yeah. I think it's not.
There's your answer, ladies and gentlemen. It's not enforced. There we go.
Not in a sense as you would imagine in many other countries. So it's you hand in your LCA estimation, and we expect, like everything else, we expect it to be right. I mean, your static, how do you call it? When you make your static, your structural analysis, you also need to hand that in. That's also not really checked. You might be drawn for a check, I think, but in general, it's mostly based on we trust that people are handing in the right numbers, and that's
very
behaving in the right
Scandinavian way to do it. It's very trusting. Very.
You're right. It is trust-based so far, but let's see what happens in the future. I would say. But again, of course, the easy question again would be this question about data. And it's about, to me, it's about educating a whole industry, the whole way through the whole value chain, across the whole value chain. This weekend we're talking about the hackathon, and it's very much a question about handling data, access to data, structuring data in an intelligent way, and that is a true journey, and it's a long-term journey, I think. So basically, it's about educating a whole industry, creating what I usually call a different license to operate. So in order to be a stakeholder within the built environment in the future, you have to be able to work at a high level with data, no matter whether you're a timber having 5 people employed or you're a big contractor in the other end of the range. You have to work with data from a completely different way, and of course that requires new skill sets, competence development, capacity building, etc., etc. And that is a long journey. I think we just have to recognize that this is not over. In a couple of years' time, right? We're looking 10, 20 years ahead, and then we can hope for the technological development being exponential, that helps along the way. So we're not talking about 20 years, maybe 15, 10 years, but it is a truly game changer in the thinking of producing high quality construction, that we are working with data across the value chain, be that the biggest company or the smallest company.
Yeah, of course. I mean, and that does bring a good point, because I mean, if you look at emissions creation in construction, 85% of emissions in construction is scope 3, right? The scope 3 being the supply chain, for those of you that don't know. So scope 1 being direct, scope 2 being indirect, scope 3 is the supply chain, which means the manufacturers, right? It's the people that make the stuff.
Yeah.
And from what I understand, and please correct me if I'm wrong, at the moment, a lot of the LCA calculations in Denmark it's a mixture of real data coming from the industry, but most of it is based off some kind of averages or some kind of way that it's approached.
I think they call it table 7 is
okay
because that's the number the government agency released it under. That's the number of the appendix, and basically they ask Aalborg University to calculate averages for typical building products.
Okay.
So what you're supposed to do is to take this table 7 and use the values out of that to make a LCA collection, so to make sure that everybody has data. If you have an IPD or you have better data, you're very welcome to use the better data, but at least you must be able to fulfill it with the.
And is there a
7.
timeline on when people can't use table 7 anymore? I mean, there must be some kind of catalyst to encourage the supply chain to digitize, right? There has to be some. Going back to carrot and stick, or as last year, as Ulla said, carrot and baseball bats, was his comment last year. So what's the encouragement, right?
Stick and baseball bats.
Stick and baseball, depending on how annoyed.
All right.
I think already from July this year, it's going to be harder to use table 7. So I think the baseball bat is in the value that you need to hit.
And why is it harder? Why is that?
Because it goes down.
Okay, because we're moving from a 12 kilogram to
8.5 and go farther
right?
down.
Okay.
So you need to think more creatively, and you need to optimize. Your budget is not that big anymore. Your budget gets smaller. You need to look into the details, and you need to get EPDs.
I like this idea of just straight away there, a carbon budget. I really like that. As you don't just have a cost budget, you now have a carbon budget based on your square meterage, which I think is a fascinating.
And you not only have an obligation, you also have a right to make that budget balance. So you have to make sure that those two budgets are balancing. But then again, zooming out, allow me just to zoom out a little bit. I think that I think over time we've discussed that the construction industry has a lot of data, but then again, it doesn't really utilize those data in an intelligent way.
90% of data is unused in construction or something like that.
So I think in the longer run, what we're talking about here is an industry fundamentally transforming its way of producing its end product. That has happened in lots of other industries over time. If you look at the music industry, the media industry, of course, etc., etc.
Absolutely.
You have seen already photo industry, blah blah blah. You've seen those transformations coming through, and of course that has to come into the construction industry over time as well. I think we are blessed with quite a lot of quite a lot of innovative companies in the industry. I think locally or regionally here in the Nordics, we are blessed with a sort of a basic model of public-private collaboration. We are cursed with a very conservative way of thinking in silos, and especially also when we talk about optimization of quality data across the stakeholders, we are cursed with this silo, this build up in silos within the construction industry. But I think people within the industry, and you might argue that that's very easily said, but we have to realize that this is a transformation that will not only take 3 or 4 or 5 years, it will take a generation, maybe even more, to think along the lines that we are going to work in order to get much more high qualitative end result, meaning the city, the construction, the building, the space, the square, whatever, the infrastructure. We also have to recognize that we have to build on budget, on time, because we are in competition with all the other industries.
Yep.
You know, as an individual consumer, I might argue, or I might choose to say, hey, should I extend my summer house with this or that project, or should I go for a vacation around the world with my family, or should I buy a new car, for that matter? Tapping into products that has experienced completely different efficiency gains over time. So we are crossing industries, and we are competing with other industries at large, not necessarily on the big projects, but going back, if you buy that logic, I think what is challenging us in the years ahead is that the budget is challenged, the national budgets are challenged, as you rightly said before. We have defense expenses, we have an aging population, we have demographics, and we have climate change, etc. And all the different initiatives, all the different products within these sort of major areas within one budget, a national budget, has to live up with certain efficiency requirements. So, you know, being within the construction industry doesn't necessarily mean that we shouldn't look to the efficiency gains in other industries. I think that is a mind shift transformation, and I think we have to live up to that in the construction industry in the years to come.
And do you think? I mean, we've discussed that, and I totally agree with your point. And one of the things that constantly frustrates me is that our productivity efficiency gains in construction is still relatively flat. I mean, it is starting to see better, and I mean, and that's also because of the responses you've just said. We also have a challenge, of course. We're lacking labor, we're lacking people, we're lacking materials. We now have a carbon budget, which kind of forces us to change. Going back very quickly, Copenhagen kind of extending their target of being carbon neutral to 2035. And to be fair, if Copenhagen does it, I'm assuming that the rest of Denmark, because you know, relatively small population, 5 million-ish from what I recall. 6. See, fact checking me again. Plus a few more. The rest of because the industry has got quite a lot of main players, it will just kind of, everyone will fall into line. Do you think in the current trajectory, it's achievable? Do you think construction in Denmark, Copenhagen and Denmark wholly will achieve that 2035 potential target, or do you think it needs a few more years of maturity? It's a hard question. It's a philosophical question, right? Because I mean, we do have the 20. The thing is like the other way around is that people go, but guys, we have this 2050 deadline to hit 1.5. Like if we do, or 2, let's say, like which is this 2050. So like, when do you? Because I think Denmark will hit it first. Right, I'm gonna. If I was a betting man,
if it's hittable, I think also it's. I think also Denmark has a good shot at hitting it first. I think 2035 Denmark will come very close. Copenhagen will come very close to that. I wouldn't bet on it that it is a 0.000 at that point, but I think it will be pretty close.
Can we do this podcast again in 2034? I'll come up with a more intelligent answer to your question.
We absolutely can. We can check our predictions in 9-10 years from now and see where we are. If podcasting is still a thing by then.
Well, if you talk about Copenhagen, the climate plan, of course, the Copenhagen climate plan reaching CO2 neutrality in 2035 is based on scope 3 as well.
Yep.
Meaning that, you know, if you and I living in Copenhagen travel abroad, has to be part of the overall CO2.
I did not know that.
No, it does.
Jesus.
So it's the individual behavior, the individual citizen behavior that really makes or breaks this carbon budget in 35, if you ask me. So, but of course, again, talking about the sort of the systemic way of moving ahead. The climate or the Paris Accord basically, pointed to the different countries, saying, "Hey, you have to have national accords on this," pointing to the regions, pointing to the municipalities. And as far as I was, I remember, I think 100% of the, is it 98 or 99 municipalities we have in Denmark? I can't really. Let's say 98.
ChatGPT now. I'm going to fact check it.
Great fact check. Saturday afternoon fact check. The number of municipalities in Denmark, 98, I would argue, has actually begun working on local climate plans. So the fact that this is sort of a trickle down effect.
Spot on, 98.
Oh my goodness!
Can you name them?
Yeah. Yes. Let's start with now.
According to ChatGPT,
according number one.
Amazing. So according to ChatGPT, in 2007, you had municipality reform reducing from 271 down to 98. Boom. There we go.
My goodness.
Something you learn every day.
License to operate.
There we go.
Okay. Anyway, that is the way to go. That's the Danish model, right? And then maybe just as a quick outro here, but I would like to argue, always remember that you cannot copy. It's not a copy exercise when you copy sort of societal systems. Because Denmark is that we talk about in Denmark. We talk about the Danish model, of having this collaboration across both employers and workers, the public, private domain, etc., etc. You cannot boost transformation globally by exporting national systems or national models, of course. So we have a very special model in Denmark. We have a very special model in the Nordics, and we like that. We develop that. We innovate on that, but it cannot be copied necessarily elsewhere.
Yeah,
and you have to remember that also when you.
Well, I mean, being a British person, we tried that for 200 years with mixed results.
And look where that brought you.
So
sorry.
I'm not. No comment. I'm not going to go down that road. I think one of the interesting things is today in Blogs Hub we had a session earlier about being a mentor or a mentoree, and about leadership. And one of my interesting things is if you look at the BIM movement, the digitalization movement, a lot of countries, namely the UK and a few others, kind of stuck the flag out and kind of said, we are going to export knowledge. Do you feel that Denmark is now in a position where you're doing some great things, and really maybe globally people should be looking at Denmark at understanding their processes and how they're legislating and how they're moving with an industry over time? Do you think that's what Denmark should be doing and maybe you are doing it already? Maybe.
You mean from a construction perspective?
Specifically from construction, but if you want to answer it more generally from a societal perspective, or without copying societal models, as you just said there, Torben. So I mean, answer it whichever way you want.
I think from a societal model, there are quite a few examples on how this progressiveness, like the windmills, like Vestas and similar, that it has succeeded. I think from a construction perspective, I think we haven't succeeded yet to productify sustainability in a similar way as a windmill is a productified thing. So I'm not. I mean, we're always seeing our famous Danish architects going everywhere and building prestigious buildings, but I'm not seeing it as a big export thing yet. I think what we more have been seeing is that Denmark is becoming more and more an import nation when it comes to construction. So for foreign contractors, foreign workers coming into the market, I would very much like to see this as and I think the time is right, and I hope that people in Covey and Rambøll and also the big architects are thinking about that currently. So how can we spread our knowledge to the world? We haven't seen it in a big way yet, at least.
And that is very true. I do think, though, that people are looking towards Denmark for more systemic solutions. In Blogs Hub, we're quite occupied with welcoming international delegations coming to Copenhagen, especially looking at how to create a livable city. A few years ago, we all talked about smart cities. We would argue that a smart city is a livable city, or the other way around, right? So it's not necessarily to do with zooming in on the individual piece of intelligent transport system or the individual, sensor being in open space. It's a more systemic way of approaching how to create cities that are livable for people, that are climate resistant, that are efficient on their energy use, etc., etc. And that is in great demand, and people are really queuing up. International delegations are queuing up to visit Copenhagen and Denmark, Aarhus, Odense, Sønderborg, not the least, Aalborg, etc., etc., to have a look at how do you do that. And as you rightly said, actually sticking your head out saying we want to be climate neutral in X years to come, that actually helps it. So the biggest leverage for the technological movement of a city of Copenhagen has not been the smart city movement, if you ask me. That's been the fact that Copenhagen, the city of Copenhagen, stuck their head out in 2012 saying in 30 years' time, 2025, we want to be the first ever CO2 neutral city at all. That spawned the technological movement.
It's that catalyst and that firework.
It's a catalytic movement. And did we get there in time? No, we didn't. But we are definitely on the move.
Yeah.
So
systemic
solutions are out there in great demand.
Super. There's a few audience members we have here. Does anybody have any questions for us or the panel? I have one question left in case no one has anything to ask. But there is an opportunity. Eske will throw a microphone over. Just introduce yourself, your name very, very quickly, and please go ahead and ask us the question.
Thank you. So I'm Florian Bucher, a student in urban planning from Hamburg, and I'd be interested how BlocksUp and Contact Lab fit into the picture between public and private sectors, and especially when the legislation is done. Say, for example, the CO2 numbers have to go down and so on. Do such organizations play a role? Are you consulted? Are you part of these processes? And what's your role in all this?
Great question.
That is a great question, and I think you're tapping into something quite rare, because lots of people come here and say, "Are you a public entity? Are you a private entity? Whatever are you?" And my answer normally is, we are neutral. So that is the new thing here, because that is wanted in so many cities, neutral platforms for public and private entities to come to seek, to embrace in order to solve systemic solutions. So we are non-political, we are not for profit for that matter also, and we are very, very neutral in the sense that we are not representing either the public nor the private sector as such, but we have them, of course, in our community in order for them to collaborate.
I think my answer would be a little bit similar. We are also a neutral place and definitely not a political place. We also see ourselves as a knowledge center, a knowledge place that also tries to to answer questions if we are asked them in an objective scientific knowledge driven way. So we see our role to show mostly to the companies in the Danish industry that it actually is possible to fulfill the legislation, and we look together with the companies for solutions that make it easier to fulfill legislation, and see that a bit our role is to drive the sustainability agenda by showing it's actually possible to estimate to calculate your CO2 consumption from the construction sites, which is one of the new requirements from July.
If I may just add, reaching the end here, I think where the basic construction of BlocksUp, for those of you who don't know, that is the founding partners is the philanthropic organization Realdania, based here in Copenhagen, and the city of Copenhagen, and the Ministry of Business and Financial Affairs. And the reason why the Ministry of Business and Financial Affairs has sort of onboarded our project here is for Danish companies to seek internationalization and expanding on a global scale, and for us to feed back innovative ideas, challenges within the industry to the legislators, to the national, to the parliament, essentially, in order for them to be more informed of, okay, what are the do's and don'ts in new legislation and in new strategies, suggestions, etc. Testing how does the industry react to this or that legislation.
No, super. So final closing point and final question before we wrap up. If you had free market decision, what kind of decision do you think or thing would really be a catalyst in driving construction to be a lower carbon emitting industry? And before you answer, I'll let you kind of think about that, because I'll give my answer first to that question.
Can we just split up a couple of hours and then come back?
You can, but no is the answer. You can't.
Okay.
I mean, so for me, it's the boring answer being the co-founder of Zero. For me, it's education and empowerment. For me, it's just getting people to understand and learn what they can and can't do, or what they should or shouldn't do tomorrow to move the needle 1%. That for me is, I think, the big thing. It's about people. It's not about tech, although I do work for a tech company, which means I might be fired on Monday for saying this. But I think, yeah, it is tech, but it is about people and understanding that. So that's my position always. It is about the people and about learning. But what's your thoughts?
I think it's very much about the financial system as well, and I think a big part that the building industry is transforming in the private sector and the company part of it is also that the financial sector is pushing it. And if you ask what do I want to see, I think I want to see a similar thing to the private market. I want to see a similar thing to electric car loans for renovation projects, not only focusing on energy renovation, but focusing on much more factors, factoring in much more different factors in terms of sustainability. And I think that will drive it even more, and that will also get all the SMEs, which we are currently discussing, which are not on board yet. That will also get them on board in thinking into more sustainable building methods.
Nice, Torben?
That was a good wish. Well, I think if I have to nail it down to one word, it would be cohesion. I think cohesion, public-private collaboration, of course, as we've discussed several times during this interview, and also, of course, across the value chain. I think tapping into Ole's last remarks, I think what could be labeled as the dark matter of the industry, everything sort of below what you can see, regulatory infrastructure, national government legislation requirements, building codes, tender procedures, financial models, not the least. I think the level of innovation and the speed of innovation is no way near leveling the speed of innovation above the ground, so to speak. When we look at what's going on this weekend here in Bloxhub, the level of innovation and the speed of innovation is immense.
Yeah,
think about that going on within the regulatory setup. That will truly be a game changer. So how can we make sure that all the great innovation going on above ground, so to speak, is more or less balanced, or the other way around? What the level of innovation on the regulatory framework has the same speed of change. Of course, it cannot change with the same speed, of course, because regulation has to be, holding a certain horizon. Of course, I thoroughly acknowledge that. But I would love to have more focus on regulatory experiments and regulatory innovation in general, in order to get to the common goal.
I think that's a really good point. I've had the joyful experience of working a little bit on the predecessor to ISO 19650, which was PAS 11.
And you're still here.
I am still here. And what makes me quite interested is that if you look at technology, you have basically technological refresh every 18 months-ish, but regulatory at an ISO level is 5 years minimum change. Like, I think that's so it's quite a long time. Look, we've pretty much up on time, right? Or probably over time. So right. Esker's going to scream at me, but I just want to say very quick thank you to Torben, very quick thank you to Ole. Come back in 2034 when we discuss if we were accurate in our predictions, or if Copenhagen is on target. It's a pleasure, as always, and give these gentlemen a very quick round of applause. Thank you very much.
Thank you.
Thank you guys, Ole Barat, Matthew Jackson, and Torben Klitgaard. That was everything for today. We will continue tomorrow at 1 o'clock. So tune in on the live stream and make sure to see all of the cool presentations. And connect to these guys if you would like to tap into this discussion. Regulatory innovation. That sounds quite awesome. Let's do it, guys.
Let's do it next year.
Thank you for today. Thank you,
Thank you.
guys.
Thank you. And thanks to the audience.